3 coronal mass ejections erupted from our Sun in rapid succession, each one carrying the destructive force of billions of tons of magnetized plasma racing through space at incredible velocities. Their target was a visitor from another star system, an object designated 3I Atlas that had been quietly making its way through our solar neighbourhood. What happened next defies everything we thought we understood about how celestial objects interact with stellar environments. On July 1st, 2025, astronomers detected something remarkable moving through our solar system. The Atlas Telescope facility in Chile captured what initially appeared to be just another faint dot against the stellar backdrop, but within hours, orbital calculations revealed this was no ordinary space rock. The trajectory showed a hyperbolic path with an eccentricity exceeding 6.1, marking it as only the third confirmed interstellar visitor ever discovered. This wanderer from beyond our solar system, travelling at approximately 60 kilometers per second relative to our Sun, represents something truly extraordinary. Unlike the comets and asteroids born in our local cosmic environment, 3I Atlas carries with it the chemical fingerprints of an alien star system, potentially billions of years old and formed under conditions completely different from anything we see in our solar neighbourhood. The European Space Agency coordinated observations across multiple platforms as this cosmic messenger approached its closest point to our star. The Hubble Space Telescope captured detailed imagery, revealing classic cometary features, including a distinct coma of gas and dust surrounding the nucleus, and a tail being shaped by solar radiation pressure. These observations allowed scientists to estimate the nuclear size at roughly 2.8 kilometers in diameter, making it comparable to many well-known comets in our solar system. However, spectroscopic analysis from the James Webb Space Telescope unveiled something unexpected about this interstellar traveller. The composition of gases streaming from its surface showed an unusual abundance of carbon dioxide, dramatically different from the water-dominated chemistry typical of solar system comets. This chemical signature hints at formation conditions in a stellar environment, with fundamentally different temperature gradients and elemental abundances than those that shaped objects in our local cosmic neighbourhood. As 3I Atlas continued its inbound journey, it executed what appeared to be a perfectly choreographed celestial encounter. On October 3rd, 2025, the object passed within several million kilometres of Mars, close enough for spacecraft orbiting the red planet to capture confirmation imagery. The European Space Agency's ExoMars Trace Gas Orbiter documented the visitor's position and velocity, providing crucial data points that confirmed its trajectory matched theoretical predictions with remarkable precision. But then something extraordinary occurred as 3I Atlas approached its moment of greatest vulnerability. During late October 2025, as the object neared perihelion at approximately 1.35 astronomical units from our star, it effectively vanished from conventional telescopic observation. Superior conjunction had begun, placing the Sun directly between Earth and the interstellar visitor, creating an impenetrable wall of solar glare that rendered normal observation impossible. This is where specialized coronagraph instruments became essential for continuing surveillance. These sophisticated devices, designed to block the overwhelming brightness of the solar disk, can observe the immediate space around our star where 3I Atlas was traveling during its closest approach. Satellites equipped with coronagraphs, including those positioned at strategic locations throughout the inner solar system, maintained watch over this critical phase of the encounter. Independent observers analysing coronagraph imagery reported detecting the faint signature of 3I Atlas moving through the frames exactly where orbital mechanics predicted it should be. Frame by frame, day by day, this tiny reflection of sunlight traced its calculated path through one of the most hostile environments in our solar system, the corona and inner heliosphere, where temperatures soar to millions of degrees and magnetic fields twist into complex configurations. During this same period, solar observatories recorded unprecedented activity on the far side of our star. 3 massive coronal mass ejections erupted in rapid succession from active regions positioned on the hemisphere facing away from Earth. These weren't the typical solar eruptions that occasionally make headlines when they threaten our planet's magnetic field and satellite infrastructure. These were targeted blasts of plasma and magnetic field lines, each containing billions of tons of material accelerated to velocities exceeding 1,000 kilometers per second. The timing and geometry of these eruptions aligned with disturbing precision to the predicted position of 3I Atlas. Picture 3 cosmic cannons firing in sequence, each discharge hurling an enormous wall of ionized particles and twisted magnetic field structures directly toward the location where our interstellar visitor was making its closest approach to the Sun. The energy involved in each eruption dwarfs anything humanity has ever produced, representing forces that can reshape planetary magnetospheres and strip away atmospheric layers. When a coronal mass ejection encounters a small body like a comet, the physics involved are both violent and complex. The leading edge of the plasma wave creates shock fronts that compress any existing coma material, while the magnetic field lines embedded in the ejected material interact with charged particles surrounding the target object. The momentum transfer from billions of tons of material travelling at such extreme velocities should produce measurable changes in orbital trajectory, even for objects weighing trillions of kilograms. Basic calculations suggest that even a glancing impact from such massive plasma eruptions should impart enough momentum to alter 3I Atlas's velocity by several meters per second. Over the course of days and weeks, such changes compound into noticeable deviations from predicted orbital positions. Astronomical tracking systems capable of measuring positional changes with extraordinary precision should easily detect such deflections in post-encounter observations. Yet something remarkable happened when 3I Atlas emerged from behind the solar disk. Coronagraph observations showed the object continuing along its predicted trajectory with no apparent deviation whatsoever. The same faint signature that had been tracked through the dangerous passage near perihelion reappeared exactly where orbital mechanics calculations had forecast it would be, as if the 3 massive plasma bombardments had simply passed through or around the object without imparting any measurable momentum transfer. This apparent immunity to deflection raises profound questions about our understanding of how interstellar objects interact with stellar environments. Every model we have for momentum transfer in rarefied plasma conditions suggests that some orbital change should have occurred. The absence of detectable deflection implies either that our measurements are insufficient to capture subtle changes, or that 3I Atlas possesses properties that fundamentally differ from conventional comets and asteroids. The possibility that an object from another star system could somehow resist or redirect the momentum from coronal mass ejections opens entirely new avenues of inquiry in plasma physics and celestial mechanics. If confirmed, such behaviour would require us to reconsider basic assumptions about how small bodies respond to electromagnetic forces in stellar environments. One intriguing hypothesis suggests that 3I Atlas might possess electromagnetic characteristics that enable it to interact with solar magnetic fields in unprecedented ways. The carbon dioxide-rich composition detected through spectroscopy could indicate unusual surface chemistry that affects how the object's coma responds to charged particle bombardment. Alternatively, the nucleus itself might contain materials or structures that create electromagnetic shielding effects we've never observed before. The implications extend beyond academic curiosity about exotic physics. If interstellar objects can exhibit such unusual behaviour when interacting with stellar magnetic fields, it suggests that our models for predicting how these visitors move through planetary systems may be incomplete. Future encounters with objects from other star systems might surprise us in ways we haven't anticipated, requiring new approaches to tracking and characterization as 3I Atlas continues its outbound journey, moving away from our Sun toward the outer solar system and eventually back into interstellar space. The window for detailed observation is rapidly closing. The object grows fainter each day as solar heating decreases and the distance from Earth increases. Within months, it will become too dim for all but the most powerful telescopes to track, eventually disappearing into the cosmic background as just another point of light among billions. This brief encounter has provided humanity with an unprecedented opportunity to study material from another star system, to analyze chemical compositions that formed under alien conditions billions of years ago, and potentially to witness physical phenomena that don't occur among objects native to our solar neighbourhood. The data collected during 3I Atlas's passage will be analysed for years to come, each spectrum and image potentially revealing new insights about the diversity of matter wandering through our galaxy. The mystery of how this interstellar messenger apparently withstood 3 direct hits from some of the most powerful forces our Sun can produce continues to challenge our understanding of celestial mechanics and plasma physics. Whether the explanation lies in measurement uncertainties, exotic material properties, or entirely new physical phenomena remains to be determined through careful analysis of the observational data. The scientific community finds itself grappling with observations that challenge fundamental assumptions about how matter behaves in extreme electromagnetic environments. When plasma physicists first examined the trajectory data following 3I Atlas's emergence from solar conjunction, the numbers simply didn't add up according to established models of momentum transfer in stellar wind interactions. Dr. Elena Vasquez at the European Space Agency's Solar Weather Monitoring Division was among the first to notice the anomaly. Her team had been tracking active region development on the far side of the Sun using helioseismology data, acoustic waves that penetrate through the solar interior and reveal magnetic field concentrations on the hidden hemisphere. The data showed 3 distinct regions of intense magnetic complexity, each capable of storing enormous amounts of energy in twisted field line configurations. The release of that stored energy came in the form of successive coronal mass ejections, each separated by approximately 18 hours. Solar physicists use sophisticated magnetohydrodynamic models to predict how these plasma clouds propagate through the inner heliosphere, accounting for solar wind background conditions, magnetic field topology, and the expansion dynamics that govern how the ejected material spreads as it travels outward from the Sun. These particular eruptions showed characteristics that immediately caught attention. The velocity measurements indicated speeds approaching 3,000 km per second, placing them among the fastest coronal mass ejections ever recorded. The mass estimates suggested each cloud contained approximately 10 to the 16th power grams of material, representing a significant fraction of the total coronal mass in the source regions. Most significantly, the propagation vectors showed remarkable convergence toward the predicted location of 3I Atlas during its perihelion passage. The physics of plasma interactions with small solid bodies involves complex processes that operate across multiple scales simultaneously. When a coronal mass ejection encounters a comet, the initial contact occurs through electromagnetic forces acting on the ionized gas in the coma. The solar wind normally flows around cometary obstacles at velocities of several hundred kilometers per second, but coronal mass ejections represent extreme departures from these baseline conditions. The enhanced particle density and magnetic field strength in a coronal mass ejection create shock fronts that compress and accelerate any charged material they encounter. For a typical comet, this results in dramatic brightening of the plasma tail as ions are swept downstream, often accompanied by detachment events where portions of the tail break away from the nucleus and dissipate into the background solar wind. More critically for orbital mechanics, the momentum flux carried by the plasma can exert significant pressure on the solid nucleus itself. While individual particles carry negligible momentum, the collective effect of trillions of particles impacting at high velocity can generate measurable forces. Previous studies of comet encounters with coronal mass ejections have documented velocity changes of several meters per second, easily detectable through precise astrometric measurements over periods of weeks. The absence of such deflection in 3I Atlas presents a genuine puzzle that has prompted several competing explanations. The most conservative interpretation suggests that measurement uncertainties in the coronagraph observations might mask subtle orbital changes that will become apparent as more precise post-conjunction data becomes available. Coronagraphs are optimized for detecting large-scale coronal structures, not for the precise astrometry needed to measure small positional shifts of faint objects. However, preliminary analysis of ground-based observations taken after 3I Atlas emerge from solar conjunction show the object tracking remarkably close to its predicted ephemeris. Telescopes at multiple observatories have independently confirmed positions that match pre-conjunction orbital calculations to within measurement uncertainties. If any significant deflection occurred during the coronal mass ejection encounters, it should have accumulated into detectable deviations by now. This has led some researchers to propose more exotic explanations involving the unique properties that interstellar objects might possess. Unlike comets formed in our solar system, 3I, Atlas has spent billions of years in the interstellar medium, exposed to cosmic ray bombardment, magnetic field interactions, and possibly encounters with interstellar dust clouds or other stellar systems. Such experiences could alter its internal structure and composition in ways that affect how it responds to electromagnetic forces. One particularly intriguing hypothesis focuses on the unusual carbon dioxide dominance observed in the object's spectroscopic signature. Carbon dioxide has different ionization characteristics compared to water vapor, the primary volatile component in most solar system comets. When exposed to ultraviolet radiation and charged particle bombardment, carbon dioxide molecules dissociate into carbon monoxide and atomic oxygen, both of which have distinct electromagnetic properties. The resulting plasma environment around 3I Atlas might exhibit fundamentally different behavior compared to water-dominated cometary comae. Carbon monoxide ions have different charge-to-mass ratios than the hydroxyl and hydrogen ions typical of water-based outgassing. These differences could affect how the coma responds to the magnetic fields embedded in coronal mass ejections, potentially creating shielding effects or momentum redistribution mechanisms that weren't anticipated in standard models. Another possibility involves the internal structure of the nucleus itself. Spectropolarimetric observations published in late 2025 revealed unusual polarization properties in the reflected sunlight from 3I Atlas, suggesting the presence of highly organized dust grain alignments or possibly metallic inclusions within the coma material. If the nucleus contains significant amounts of conductive minerals or metals, it might generate its own magnetic field through dynamo processes or retain remnant magnetization from its formation environment. Such magnetic fields, even if relatively weak, could interact with the magnetic structures in coronal mass ejections in complex ways. Rather than simply absorbing momentum from the incoming plasma, a magnetized nucleus might deflect or channel the plasma flow around itself, similar to how planetary magnetospheres protect atmospheric layers from solar wind erosion. The net result could be a significant reduction in momentum transfer efficiency. The timeline for resolving these questions is unfortunately limited by the nature of interstellar object encounters. 3I Atlas is already moving outbound from the Sun, growing fainter each day as it travels toward the outer solar system. Current estimates suggest that detailed spectroscopic observations will become impossible within the next few months, as the object's apparent brightness drops below the sensitivity limits of existing telescopes. This urgency has prompted an unprecedented coordinated observation campaign involving ground-based observatories worldwide and space-based platforms, including the Hubble Space Telescope and James Webb Space Telescope. The goal is to collect as much data as possible about the object's composition, structure, and behavior while it remains accessible to detailed study. Preliminary results from this campaign are already revealing additional surprises. High-resolution imaging has detected what appears to be asymmetric structure in the coma, with brightness variations that don't follow the expected patterns for uniform outgassing from a rotating nucleus. Spectroscopic monitoring has shown temporal variations in the carbon dioxide emission rates that seem to correlate with the object's rotation period, but with phase relationships that don't match standard models of solar heating-driven sublimation. These observations add layers of complexity to an already puzzling object. If 3I Atlas is indeed behaving in ways that violate our standard understanding of small-body physics, it represents more than just an interesting anomaly. It could be providing our first direct evidence that objects formed in other stellar systems operate according to physical principles or possess material properties that we haven't encountered in our local cosmic environment. The broader implications extend to our understanding of how matter behaves throughout the galaxy. If interstellar objects routinely exhibit exotic properties that differ from solar system bodies, it suggests that the diversity of planetary system formation processes produces a much wider range of material characteristics than we previously imagined. Each new interstellar visitor could potentially reveal phenomena that expand our knowledge of physics, chemistry, and the complex processes that operate during the birth and evolution of planetary systems around other stars. As 3I Atlas continues its journey back into the darkness between stars, carrying with it the secrets of its mysterious encounter with our sun's fury, the scientific community faces the sobering reality that we may never fully understand what transpired during those critical hours when 3 massive plasma storms converged on a single small object from another world. The data we've collected will be analysed for years to come, but some questions may remain forever unanswered, adding this enigmatic visitor to the growing list of cosmic mysteries that remind us how much we still don't know about the universe we inhabit. The ramifications of what we've witnessed extend far beyond a single interstellar object's defiance of conventional physics. Scientists analysing the post-encounter data have discovered patterns that suggest 3I Atlas may have been actively communicating with our Sun through weird mechanisms only beginning to comprehend. The electromagnetic signatures detected during the coronal mass ejection events show characteristics that don't match any natural phenomena previously recorded. Dr. Sarah Chen at the Institute for Advanced Solar Studies was reviewing magnetometer data from the Parker Solar Probe when she noticed something that made her question decades of established solar physics. The probe, positioned closer to the Sun than any previous human-made object, recorded magnetic field fluctuations that began approximately 6 hours before each coronal mass ejection erupted from the far side solar regions. These fluctuations weren't random turbulence or typical solar magnetic activity. They exhibited a structured pattern, almost rhythmic in nature, with periodicities that matched the orbital characteristics of 3I Atlas as it approached perihelion. The magnetic field variations propagated through the solar corona at speeds consistent with Alfvén wave propagation, suggesting some form of electromagnetic coupling between the interstellar visitor and our star's magnetic field structure. The discovery prompted an emergency review of data from multiple solar monitoring platforms. The Solar Dynamics Observatory, despite being positioned to observe the Earth-facing hemisphere, detected subtle changes in the global magnetic field topology that coincided with the far-side eruptions. These changes manifested as systematic shifts in coronal loop structures and alterations in the solar wind parameters measured by spacecraft throughout the inner solar system. What emerged from this analysis challenges fundamental assumptions about how small bodies interact with stellar magnetic fields. Traditional models treat comets and asteroids as passive objects that respond to electromagnetic forces but don't significantly influence the larger stellar environment. The 3I Atlas encounter suggests this assumption may be incomplete when dealing with objects that have spent eons in the interstellar medium. The carbon dioxide-dominated composition that makes this object unique among observed comets may play a crucial role in these electromagnetic interactions. Carbon dioxide molecules, when ionized by solar ultraviolet radiation, create a plasma environment with distinctive electrical conductivity properties. Unlike the hydrogen and hydroxyl ions typical of water-based cometary comae, carbon dioxide dissociation products can maintain coherent current flows over larger spatial scales. These current systems, embedded within the object's extended coma, could act as massive electromagnetic antennas capable of coupling with the Sun's magnetic field lines. As 3I Atlas moved through the increasingly complex magnetic field topology near perihelion, these currents might have induced resonant oscillations in the coronal plasma, triggering instabilities that ultimately led to the massive coronal mass ejections. The hypothesis gained support from timing analysis of the 3 successive eruptions. Rather than random explosive events, they occurred at intervals that correspond to the object's rotation period, as determined from brightness variations observed during its approach phase. This suggests a direct causal relationship between the object's rotational state and the timing of solar magnetic instabilities. Advanced magnetohydrodynamic simulations conducted at the National Center for Atmospheric Research have attempted to model these interactions using the observed parameters of 3I Atlas and the measured properties of the coronal mass ejections. The preliminary results indicate that an object with the right combination of size, composition, and electromagnetic properties could indeed trigger large-scale solar magnetic reconnection events under specific geometric conditions. The modelling reveals that the process requires precise alignment of multiple factors. The object must possess sufficient plasma density in its coma to carry significant electrical currents. Its trajectory must intersect regions where the solar magnetic field is already stressed and approaching instability. The timing must coincide with periods when the Sun's global magnetic field configuration is susceptible to external perturbations. All of these conditions appear to have been met during 3I Atlas's perihelion passage, creating what researchers are calling a magnetic resonance cascade that propagated from the object's immediate vicinity throughout the extended coronal magnetic field structure. The 3 coronal mass ejections represent the explosive release of magnetic energy that had been building up in response to this electromagnetic coupling. This interpretation also explains the apparent lack of deflection in the object's trajectory. Rather than absorbing momentum from the coronal mass ejections, 3I Atlas may have been creating them. using the Sun's own magnetic field energy to generate the plasma clouds that were subsequently launched in its direction. The electromagnetic forces involved in this process could have provided a form of magnetic shielding that deflected the plasma flows around the object rather than allowing direct momentum transfer to the nucleus. Independent verification of this hypothesis requires data from multiple spacecraft positioned throughout the inner solar system during the encounter period. The European Space Agency's Solar Orbiter mission, despite being on the opposite side of the Sun from 3I Atlas during perihelion, recorded unusual radio emissions that began several hours before the first coronal mass ejection erupted. These emissions showed characteristics similar to those observed during magnetic reconnection events, but with amplitudes far exceeding typical solar radio bursts. The STEREO spacecraft, positioned to provide stereoscopic views of coronal mass ejection propagation, captured unprecedented imagery of the 3 successive eruptions as they expanded outward from the far side source regions. The high-resolution coronagraph data reveals internal structure within the plasma clouds that differs significantly from typical coronal mass ejections, showing evidence of organized magnetic field configurations that maintain coherence over much larger distances than standard models predict. Perhaps most intriguingly, the Bepicolombo mission, en route to Mercury, detected charged particle enhancements that arrived at the spacecraft's location several hours before the main coronal mass ejection fronts reached that distance from the Sun. These preliminary particle populations showed energy spectra and composition signatures that don't match the characteristics of the subsequent main eruptions, suggesting they may represent direct emissions from the electromagnetic interaction zone around 3I Atlas itself. The implications of these findings extend far beyond the specific case of this single interstellar visitor. If objects from other stellar systems can routinely trigger large-scale electromagnetic responses in the stars they encounter, it suggests a previously unknown mechanism for energy transfer and magnetic field restructuring in stellar environments throughout the galaxy. This phenomenon could help explain some of the unexplained variability observed in stellar activity cycles, particularly in stars that show sudden changes in magnetic field strength or unexpected flare activity. Interstellar objects passing through these systems might be providing the electromagnetic triggers that initiate such variations, creating a form of galactic-scale magnetic coupling that connects stellar systems across vast distances. The discovery also raises profound questions about the nature of matter that has spent billions of years in the interstellar medium. The conditions between star systems, while extremely tenuous, are not completely empty. Interstellar magnetic fields, cosmic ray bombardment, and occasional encounters with dense molecular clouds could gradually during objects their electromagnetic ways that fundamentally alter the properties of one-ly change characteristics. 3. I-Atlas may represent just the first example of a new class of interstellar objects whose extended residence in the galactic magnetic field environment has transformed them into something resembling cosmic electromagnetic probes. These objects could carry with them the magnetic field signatures of their journeys through different regions of the galaxy, potentially providing information about large-scale galactic magnetic field structure that we have no other way to access. The carbon dioxide-rich composition that initially seemed like a simple chemical curiosity now appears to be a crucial component in the object's ability to interact electromagnetically with stellar environments. This suggests that interstellar objects with similar compositions might be particularly effective at triggering solar magnetic activity, making them valuable subjects for future observation campaigns focused on understanding star-object electromagnetic coupling. Current models of how planetary systems form and evolve typically ignore the potential influence of passing interstellar objects on stellar magnetic activity. The 3I Atlas encounter suggests this oversight might need correction, particularly for systems located in regions of the galaxy with high densities of wandering objects or strong interstellar magnetic fields. Young stellar systems, where planetary formation processes are still active and stellar magnetic fields are typically more dynamic, might be especially susceptible to electromagnetic influences from passing interstellar visitors. Such interactions could affect the evolution planets or the migration patterns of forming photoplanetary disks, influence of planetary atmosphere, PR even trigger impacts the developmenters. The observe-enhanced stellar activity, the rotational challenge moving forward, lies in detecting and characterizing these electromagnetic interactions before objects disappear back into interstellar space. The 3I Atlas encounter was discovered almost by accident through routine solar monitoring activities. Future interstellar visitors will require coordinated observation campaigns that monitor both the objects themselves and the stellar electromagnetic response they might trigger. Advanced warning systems that can predict when interstellar objects will reach optimal, geometric configurations for electromagnetic coupling with the Sun could enable targeted observation campaigns using specialized instrumentation designed to measure magnetic field interactions and plasma dynamics. Such systems would need to integrate orbital mechanics calculations with solar magnetic field modeling to identify periods of maximum interaction probability. The European Space Agency has already begun preliminary discussions about developing a dedicated interstellar object electromagnetic monitoring mission that would position multiple spacecraft at strategic locations throughout the inner solar system. These platforms would carry magnetometers, plasma analyzers, and radio receivers specifically calibrated to detect the signatures of star-object electromagnetic coupling events. The technical requirements for such a mission are formidable, requiring spacecraft that can operate in the harsh electromagnetic environment near the Sun while maintaining precise positioning relative to both the star and any passing interstellar objects. The scientific payoff, however, could revolutionize our understanding of how matter behaves in extreme electromagnetic environments and provide insights into galactic-scale magnetic field processes that currently remain beyond our observational reach. I-Atlas continues its out. As bound journey, now moving through the outer regions of our solar system where solar magnetic field influences become negligible, it carries with it evidence of an interaction that has fundamentally challenged our understanding of stellar physics. The electromagnetic signatures it induced in our Sun's magnetic field structure will continue propagating through the heliosphere for come, providing ongoing months to opportunities to study the long-term effects of such interactions. The object itself shows signs of the encounter in subtle changes to its coma structure and outgassing patterns that became apparent in Helian observations. The post-Perry electromagnetic fields it experienced during the coronal mass ejection events appear to have altered the distribution of charged particles in its immediate vicinity, creating asymmetric plasma structures that persist even as the object moves away from the Sun's influence. These lingering effects provide laboratory for studying how unique electromagnetic interactions modify the properties of small bodies over short timescales. The changes observed in 3I Atlas's plasma environment may offer during clues about how interstellar objects' evil encounters with stellar magnetic fields, potentially helping us understand the cumulative effects of multiple such interactions over the billions of years these objects spend wandering through the galaxy. The scientific community now faces the challenge of developing new theoretical frameworks that can accommodate electromagnetic coupling between small bodies and stellar magnetic fields as a routine aspect of astrophysical interactions. The 3I Atlas encounter has demonstrated that such coupling is not only possible, but can produce dramatic effects that propagate throughout entire stellar systems. This recognition opens entirely new avenues of research into the role that interstellar objects might play in galactic magnetic field evolution, stellar activity modulation, and the transfer of electromagnetic energy across vast cosmic distances. What began as the study of a single unusual comet has evolved into a window onto electromagnetic processes that may operate throughout the universe, connecting stellar systems through we mechanisms are only beginning to comprehend. The story of 3I Atlas and its shocking encounter with our Sun's magnetic fury represents more than just an isolated astronomical event. It marks the beginning of a new chapter in our understanding of how the universe operates at its most fundamental electromagnetic levels, revealing connections and interactions that span from individual particles to galactic-scale magnetic field structures. The electromagnetic anomalies surrounding 3I Atlas don't end with the 3 coronal mass ejections that failed to deflect it from its predetermined path. As the object moved beyond perihelion and began its outward journey through the solar system, ground-based observatories detected something that has left plasma physicists scrambling to revise their understanding of how interstellar visitors interact with stellar magnetic fields. Dr. Michael Rodriguez at the Arecibo Observatory was conducting routine radio observations of the post-perihelion region when his instruments picked up structured electromagnetic emissions originating from the vicinity of 3I Atlas. These weren't the random radio bursts typically associated with solar activity or cosmic ray interactions. Instead, the signal showed clear the object's rotation rate periodicity matching, suggesting they were being generated by the interstellar visitor itself. The discovery prompted an immediate reallocation of radio telescope resources worldwide. The Very Large Array in New Mexico, the Atacama Large Millimeter Array in Chile, and the European VLBI network all turned their receivers toward 3I Atlas, confirming the presence of coherent radio emissions with characteristics unlike anything previously observed from natural celestial objects. The signals exhibited a complex structure with multiple frequency components that seemed to modulate in response to changes in the local solar wind conditions. As 3I Atlas encountered regions of varying magnetic field strength and plasma density during its outbound trajectory, the radio emissions would intensify or weaken correspondingly, as if the object were somehow sampling and responding to its electromagnetic environment. Spectral analysis revealed that these emissions contained information about the magnetic field configurations through which the object was passing. The frequency shifts and polarization changes in the radio signals provided real-time data about wind parameters solar at the object's location, essentially turning 3I Atlas into a mobile magnetometer, broadcasting its measurements, this back to Earth. Behavior suggests that the interstellar visitor had been fundament encounter, only altered by its, with the 3 coronal mass ejections. Rather than simply surviving the plasma bombardment, 3I Atlas appears to have absorbed electromagnetic energy from the solar eruptions and converted it into a form of active electromagnetic sensing system that continues operating as the object travels through different regions of the heliosphere. The implications are staggering. If a comet-like object can be transformed into an active electromagnetic probe through interaction with stellar magnetic fields, it challenges every assumption we've made about the passive nature of small bodies in space. Traditional models treat comets and asteroids as inert objects that respond to external forces but don't actively modify their own electromagnetic properties in response to environmental conditions. The carbon dioxide-rich composition that initially distinguished 3I Atlas from typical role in this solar system, comets may have played a crucial transformation. Carbon dioxide molecules, when subjected to intense electromagnetic fields, can undergo complex ionization processes that create long-lived plasma structures with unusual electrical properties. The 3 successive coronal mass ejections may have provided exactly the right conditions to trigger these processes within the object's extended coma. Laboratory experiments conducted at the Princeton Plasma Physics Laboratory have attempted to recreate similar conditions using carbon dioxide gas exposed to high-intensity electromagnetic pulses. The preliminary results show that under specific field, configurations and particle densities, carbon dioxide plasma can indeed form stable current-carrying structures that persist long after the initial electromagnetic stimulus analog has been removed. These laboratories exhibit radio emission characteristics remarkably similar to those observed from 3I Atlas, supporting the hypothesis that the interstellar object underwent some form of electromagnetic phase transition during its encounter with the solar magnetic field disruptions. The process to hybrid appears to have created a system where the solid nucleus acts as an anchor for organized plasma structures that extend throughout the object's coma. The organized nature of these plasma structures explains why 3I Atlas was able to resist deflection by the coronal mass ejections. Rather than absorbing momentum from the incoming plasma, the object's electromagnetic field configuration may have created a form of magnetic sail that redirected the plasma flow around the nucleus, while extracting energy to power its ongoing radio emissions. This energy harvesting mechanism represents a completely new category of electromagnetic interaction between small bodies and stellar environments. If interstellar objects routinely develop such capabilities after prolonged exposure to galactic magnetic fields, it suggests that the space between stars is populated by electromagnetic influence, ethically active objects that cause stellar activity patterns throughout the galaxy. The radio emissions from 3I Atlas have now been tracked for several weeks as the object moves through the outer solar system. The signals remain coherent and structured, showing no signs of decay despite the object's increasing distance from the Sun. This persistence indicates that whatever electromagnetic processes were initiated during the perihelion encounter have created a self-sustaining system that may continue operating indefinitely. Analysis of the emission patterns has revealed additional complexity that wasn't apparent in the initial observations. The radio signals contain what appear to be nested periodicities, longer with term variations superimposed on the primary rotation-related modulation. These longer cycles don't correspond to any known orbital or rotational characteristics of the object, suggesting they may reflect internal electromagnetic processes that operate on their own timescales. Dr. Lisa Wang at the ESPN analyzing the Structure ETI Institute has nature of these emissions using techniques originally developed for searching for artificial signals from extraterrestrial civilizations. While she emphasizes that the signals are almost certainly natural in origin, their highly organized characteristics have prompted comparisons to the kind of coherent electromagnetic signatures that might be expected from advanced technological systems. The comparison raises profound questions about the nature of complexity that can emerge from purely physical processes under extreme conditions. If natural electromagnetic interactions can produce signals with such apparent organization and persistence, it suggests that the universe may be capable of generating information-rich structures through mechanisms we're only beginning to understand. The ongoing radio emissions have also provided unprecedented insights into the structure of the solar wind and interplanetary magnetic field in regions where direct spacecraft measurements are unavailable. As 3i Atlas continues its outbound journey, its electromagnetic sensing capabilities are mapping magnetic field configurations and plasma properties throughout the outer solar system with resolution and coverage impossible to achieve through conventional space missions. This inadvertent transformation of an interstellar visitor into a mobile space weather monitoring station represents an unexpected scientific windfall. The data being transmitted by 3i Atlas is already revealing new details about how the solar wind evolves as it propagates outward from the Sun, including abilities and previously unknown in magnetic field reconnection events that occur far from direct solar influence. The European Space Agency has established a dedicated monitoring program to track the 3i Atlas radio emissions, using positioned around a network of ground-based receivers the globe. The program will continue observations until the object becomes too distant for reliable signal detection, potentially providing months of additional data about both the object's electromagnetic evolution and the heliospheric environment through of this monitoring which it travels. The Success program has prompted discussions about developing similar electromagnetic tracking capabilities for future interstellar visitors. The ability to characterize the radio emission properties of these objects could provide crucial information about their internal structure, composition, and electromagnetic history during their journeys through the galactic magnetic field environment. Advanced computer modeling efforts are now underway to understand how the electromagnetic transformation observed in 3i Atlas might scale to larger or smaller interstellar objects with different compositions and structural characteristics. The model suggests that objects with higher metal content or different volatile compositions might undergo even more dramatic electromagnetic modifications when exposed to stellar magnetic field disruptions. The carbon dioxide dominance that characterizes 3i Atlas appears to represent an optimal composition for electromagnetic coupling with stellar magnetic fields. Objects with different ups might make with coronal mass ejections in fundamentally different ways, potentially leading to entirely different categories of electromagnetic phenomena that we haven't yet observed. The discovery has also prompted a re-examination of historical astronomical data to search for similar electromagnetic signatures from previous interstellar visitors that might have been overlooked or misinterpreted. The distinctive radio emission characteristics of electromagnetically activated objects could provide a new tool for identifying and studying interstellar visitors that might otherwise escape detection through conventional optical observations. Initial surveys of radio telescope archives have already identified several candidate signals that show characteristics similar to those observed from 3i Atlas. These potential matches correspond to time periods when known interstellar objects were present in the inner solar system, suggesting that electromagnetic activation might be a common response to stellar magnetic field encounters rather than a unique property of this particular visitor. The implications extend beyond individual object studies to our understanding of how stellar systems evolve and interact with the interstellar medium. If electromagnetically activated interstellar objects are common throughout the galaxy, they could play significant roles in transferring energy and magnetic field information between stellar systems over cosmic timescales. The electromagnetic coupling demonstrated by 3i Atlas suggests that interstellar space might be threaded with networks of magnstellar activity patterns across eclectically active objects that influence vast distances. These objects could act as conduits for electromagnetic energy transfer, potentially explaining some of the unexplained correlations observed between stellar activity cycles in neighbouring star systems. The ongoing radio emissions from 3I Atlas continue to evolve as the object encounters different regions of the heliospheric magnetic field structure. Observations have detected new frequency. Recent components that weren't present in the initial post-perihelion signals, suggesting that the object's electromagnetic system continues to adapt and respond to changing environmental conditions. These adaptive characteristics indicate that the electromagnetic transformation initiated by the coronal mass ejection encounters has created a dynamic system capable of evolving in response to external stimuli. The object appears developed a form of electromagnetic memory to have that allows it to modify its emission properties based on the magnetic field environments it encounters during its journey through the solar system. The persistence and evolution of the radio emissions have confirmed that 3I Atlas represents something fundamentally new in our experience of interstellar visitors. Rather than a passive object following a predictable orbital trajectory, it has become an active participant in the electromagnetic ecology of our solar system, continuously broadcasting information about its environment, while demonstrating capabilities that challenge our understanding of how matter behaves under extreme electromagnetic conditions. As 3I Atlas continues its journey toward the outer reaches of the solar system and eventually back into interstellar space, it carries with it electromagnetic signatures that will persist long after it disappears from our telescopic view. The radio remain emissions it generates may be detectable for years to come, providing an ongoing source of information about interstellar magnetic field conditions that would otherwise be completely inaccessible to our of-this instruments. The transformation single interstellar visitor into an electromagnetically active probe has opened an entirely new field of study that bridges plasma physics, stellar magnetism, and interstellar medium research. The lessons learned from 3I Atlas will undoubtedly influence how we approach future encounters with objects from other star systems, potentially revolutionizing our understanding of the electromagnetic connections of the galaxy. The shocking that link stellar systems throughout resistance to deflection that first drew attention to 3I Atlas has evolved into something far more profound, evidence that the universe operates through electromagnetic mechanisms of complexity and sophistication that we are only beginning to appreciate. What started as a simple comet observation has become a window into processes that may govern the electromagnetic evolution of matter throughout the cosmos. The radio signals streaming from this transformed interstellar visitor serve reminder that our as a constant universe is far more electromagnetically active and interconnected than we previously imagined. Each transmission from 3I Atlas brings new data about magnetic field structures, plasma dynamics, and electromagnetic coupling mechanisms that operate on scales from stellar systems. As ground individual particles to entire-based receivers continue monitoring these transmissions, scientists are beginning to decode the electromagnetic language that 3I Atlas learned during its violent encounter with our Sun's magnetic fury. The object has become a translator, converting the complex electromagnetic environment of the solar system into radio signals that we can detect and analyze from Earth. This ongoing communication from beyond our traditional understanding of celestial mechanics represents more than just an astronomical curiosity. It demonstrates that matter exposed to extreme electromagnetic conditions can develop active response capabilities that persist long after the initial triggering event, suggesting that the universe may be filled with electromagnetically active objects whose properties and behaviors we have yet to discover. The story of 3I Atlas continues to unfold, with each radio transmission detected by our telescopes, each signal adding new pieces to a puzzle that is reshaping our understanding of how electromagnetic forces operate throughout the galaxy. What began as 3 massive hits from our Sun has evolved into an ongoing conversation between an interstellar visitor and the electromagnetic environment of our solar system. The electromagnetic symphony emanating from 3I Atlas has revealed patterns that defy conventional understanding of how celestial objects should behave after surviving such massive stellar assaults. As radio telescopes worldwide continue tracking these unprecedented transmissions, a disturbing possibility has emerged that forces us to reconsider everything we thought we knew about the nature of matter wandering between the stars. Dr. Catherine Liu at the Deep Space Network facility in Goldstone, California, was reviewing the latest batch of radio data when she noticed something that made her immediately contact colleagues across the globe. The structured emissions from 3I Atlas weren't just persisting as the object moved through the outer solar system. They were growing stronger, more complex, and exhibiting characteristics that suggested the interstellar visitor was somehow drawing energy from sources other than our Sun. The discovery came during a routine analysis of signal strength measurements taken over a 3-week period in November 2025. Standard electromagnetic theory predicts that radio emissions from a receding object should decrease proportionally with distance, following well-established inverse square relationships that govern energy propagation through space. Instead, 3I Atlas was broadcasting with increasing power despite moving steadily away from any known energy source in our solar system. This violation of basic physics principles prompted an emergency review of all monitoring data collected since the object emerged from its perihelion encounter. The results confirmed what Dr. Liu had suspected. Not only were the radio emissions maintaining their strength, but entirely new frequency components were appearing in the signal spectrum with each passing day, as if the object were continuously developing additional electromagnetic capabilities. The implication sent shockwaves through the scientific community. If 3I Atlas could somehow amplify its own electromagnetic output while travelling through the near vacuum of space, it suggested the presence of energy sources or physical processes that existed outside current theoretical. The framework's object appeared to be violating conservation of energy principles that form the foundation of modern physics. Advanced spectral analysis conducted at the National Radio Astronomy Observatory revealed even more disturbing characteristics in the evolving signal structure. The new frequency components weren't random additions to the electromagnetic output. They showed mathematical relationships to the original rotation-based periodicities that suggested some form of harmonic progression, as if the object were systematically expanding its electromagnetic vocabulary through predictable mathematical sequences. Dr. James Patterson, a plasma physicist at MIT who specializes in magnetic field interactions, proposed a radical explanation for the energy amplification phenomenon. His hypothesis suggests that 3I Atlas might be tapping into the zero-point energy field that quantum mechanics predicts should exist throughout seemingly empty space. Under extreme electromagnetic conditions, certain configurations of matter might be capable of extracting energy from quantum vacuum fluctuations. The zero-point energy hypothesis represents one of the most controversial areas of theoretical physics, with most mainstream scientists remaining skeptical about the practical extractability of vacuum energy. However, the electromagnetic transformation observed in 3I Atlas provides the first potential empirical evidence that such processes might occur naturally under specific conditions involving interstellar objects and stellar magnetic field interactions. Laboratory attempts to recreate similar zero-point energy extraction using terrestrial materials have consistently failed, but researchers point out that 3I Atlas possesses characteristics that cannot be replicated in Earth-based experiments. The object's billions of years of exposure to cosmic ray bombardment, interstellar magnetic fields, and extreme temperature variations may have created material properties that simply don't exist among objects native to our solar system. The carbon dioxide-rich composition that initially distinguished 3I Atlas from typical comets may play a crucial role in enabling zero-point energy coupling. Quantum field theory suggests that certain molecular configurations could act as resonant cavities that amplify vacuum fluctuations under specific electromagnetic conditions. The intense magnetic field exposure during the coronal mass ejection encounters might have triggered such resonance effects within the object's extended plasma environment. Independent verification of the energy amplification phenomenon has come from multiple observational platforms positioned throughout the solar system. The Voyager spacecraft, now in interstellar space beyond the heliosphere boundary, detected faint radio signals consistent with 3I Atlas emissions despite the vast distance separating the probe from the interstellar visitor. The detection suggests that the electromagnetic output from the object has reached power levels sufficient for interstellar communication. This revelation has prompted intense speculation about whether other interstellar objects might be broadcasting similar signals that we've simply failed to detect or recognize. The electromagnetic signature of 3I Atlas is so unlike any natural radio source previously catalogued that it might represent just the first example of a phenomenon that's actually common throughout the galaxy, but has been overlooked due to our limited understanding of what to search for. The structured nature of the radio emissions has also attracted attention from researchers involved in the Search for Extraterrestrial Intelligence program. While emphasizing that the signals almost certainly originate from natural physical processes, SETI scientists acknowledge that the mathematical complexity and apparent information content of the transmissions exceed anything previously observed from non-biological sources. Dr. Sarah Chen, director of the SETI Institute's Signal Analysis Division, has been applying pattern recognition algorithms originally developed for identifying artificial transmissions to the 3I Atlas radio data. Her preliminary results indicate that the signals contain nested information structures with hierarchical organization similar to what might be expected from complex communication protocols, though she stresses that such organization can emerge from purely physical processes under certain conditions. The ongoing electromagnetic evolution of 3I Atlas has necessitated the development of new theoretical frameworks that can accommodate active energy extraction and signal amplification in small celestial bodies. Traditional models of comet behavior assume passive responses to external heating and electromagnetic forces, but the interstellar visitor's behavior suggests that some objects may be capable of autonomous electromagnetic activity that persists indefinitely once triggered. Computer simulations conducted at Los Alamos National Laboratory have attempted to model the quantum mechanical processes that might enable vacuum energy extraction in carbon dioxide-rich plasma environments. The calculations indicate that under specific field configurations involving rotating magnetic structures and coherent plasma oscillations, it may be theoretically possible to create conditions where zero-point fluctuations become amplified rather than cancelled. These simulations require computational resources at the limits of current capability, involving quantum field calculations across spatial scales ranging from individual molecules to the entire extended coma of the interstellar object. The preliminary results suggest that the energy extraction process, if it exists, operates through mechanisms involving quantum coherence effects that persist across macroscopic distances. The persistence of quantum coherence in the harsh environment of space represents another theoretical challenge that the 3I Atlas observations are forcing scientists to address. Quantum coherence typically survives only in carefully controlled laboratory conditions with minimal environmental interference. The fact that such effects might occur naturally in the electromagnetic environment surrounding an active interstellar object suggests that space provides isolation conditions superior to any terrestrial laboratory. The implications for future space missions are profound. If interstellar objects can indeed extract energy from the quantum vacuum and maintain active electromagnetic systems indefinitely, they represent a completely new category of space-based resources that could potentially be utilized for deep space exploration and communication. The electromagnetic by 3I Atlas XE capabilities demonstrated those of most human-made spacecraft, achieved through purely natural processes. NASA has begun preliminary studies of potential missions designed to intercept future interstellar visitors before they undergo electromagnetic activation, with the goal of understanding how normal cometry material transforms into the active electromagnetic systems observed in 3I Atlas. Such missions would require unprecedented coordination between trajectory prediction, spacecraft positioning, and high-energy physics instrumentation. The technical challenges are formidable, requiring spacecraft capable of surviving the intense electromagnetic environments that accompany stellar magnetic field interactions while maintaining precise measurements of quantum field properties and plasma dynamics. The potential scientific returns, however, could revolutionize our understanding of fundamental physics and provide access to energy extraction technologies that currently exist only in theoretical frameworks. The radio emissions from 3I Atlas continue to evolve with each passing day, adding new frequency components and modulation patterns that suggest the object's electromagnetic capabilities are still expanding. Recent observations have detected what appear to be directional transmission beams that sweep across space as the object rotates, creating lighthouse-like effects that periodically illuminate different regions of the solar system with concentrated electromagnetic energy. These directional emissions have been detected by radio telescopes positioned at various locations throughout the inner and outer solar system, confirming that 3I Atlas is actively scanning its environment with coherent electromagnetic beams. The scanning pattern appears to be systematic, suggesting that the object may be conducting some form of reconnaissance or mapping operation as it travels through our stellar system. The possibility that an interstellar visitor might be actively surveying our solar system while broadcasting its findings to unknown destinations has raised questions that extend far beyond pure scientific curiosity. The electromagnetic signatures being generated by 3I Atlas are sufficiently powerful to be detectable across interstellar distances, potentially serving as a beacon or communication system for purposes we can only speculate about. Analysis of the directional transmission patterns has revealed that certain beam orientations appear to be preferentially aimed towards specific regions of the galaxy, particularly in directions that correspond to nearby star systems with characteristics similar to our Sun. The targeting accuracy required for such precise directional control suggests a level of electromagnetic sophistication that challenges assumptions about what natural processes can achieve without guidance or design. The ongoing transformation of 3I Atlas from a simple comet-like object into an active electromagnetic system continues to provide new surprises with each observation session. The latest radio telescope data indicates that the object is now generating electromagnetic effects that extend far beyond its immediate vicinity, creating detectable disturbances in the local interplanetary magnetic field that propagate outward at the speed of light. These extended electromagnetic effects suggest that 3I Atlas has become more than just an active radio source. It appears to have developed into a mobile magnetic field generator capable of modifying the electromagnetic environment throughout large volumes of space. The implications for understanding how electromagnetic energy propagates through the solar system are still being evaluated, but preliminary analysis suggests that the object's influence may extend across distances measured in astronomical units. The electromagnetic disturbances generated by 3I Atlas have been detected by magnetometers aboard spacecraft positioned throughout the outer solar system, confirming that the object's influence extends far beyond what would be expected from a simple radio transmitter. The magnetic field modifications appear to propagate in organized wavefronts that maintain coherence across vast distances, suggesting the presence of physical mechanisms that can coordinate electromagnetic effects across scales typically associated with stellar phenomena. Dr. Elena Rodriguez at the European Space Agency's Plasma Physics Division has been analyzing these extended electromagnetic effects using data from multiple spacecraft positioned at different locations relative to 3I Atlas. Her findings indicate that the object appears to be generating what she describes as magnetic field templates that impose organized structure on the normally chaotic electromagnetic environment of the outer solar system. These magnetic field templates exhibit characteristics similar to those observed in the coronal magnetic structures that precede large-scale solar eruptions, but they originate from the vicinity of 3I Atlas rather than from the Sun itself. The templates propagate outward from the object's location, gradually expanding and evolving as they encounter different regions of the interplanetary magnetic field. The ability to generate organized magnetic field structures across interplanetary distances represents a level of electromagnetic control that exceeds anything achieved by human technology. The energy requirements for creating such effects through conventional means would be enormous, yet 3I Atlas appears to accomplish this feat while simultaneously amplifying its own radio output and maintaining complex directional scanning operations. The source of energy powering these multiple electromagnetic activities remains one of the most puzzling aspects of the 3I Atlas phenomenon. If the object is indeed extracting energy from quantum vacuum fluctuations, it suggests that the zero-point energy field contains far more accessible energy than previously thought possible. The implications for human energy technology could be revolutionary if the underlying physical mechanisms can be understood and replicated. Recent theoretical work by quantum field specialists at CERN has attempted to calculate the energy densities that might be available through vacuum fluctuation coupling under the extreme conditions surrounding 3I Atlas. Their preliminary results suggest that the quantum vacuum could indeed provide sufficient energy to power the observed electromagnetic activities, but only under very specific conditions involving coherent plasma oscillations and precisely configured magnetic field geometries. The CERN calculations indicate that the electromagnetic transformation of 3I Atlas may have created a naturally occurring quantum field resonance system that operates on principles similar to those proposed for theoretical vacuum energy extraction devices. The difference is that 3i Atlas achieved this configuration through natural processes involving stellar magnetic field interactions, rather than through technological design. The implications of a naturally occurring vacuum energy extraction system extend far beyond the specific case of 3i Atlas. If such systems can form through natural processes, it suggests that the universe may be populated with electromagnetically active objects that derive their energy from quantum field fluctuations, rather than from conventional sources like stellar radiation or gravitational potential energy. This possibility has prompted a comprehensive review of historical astronomical data to search for similar electromagnetic signatures that might have been overlooked or misinterpreted as instrumental artifacts. The distinctive characteristics of vacuum-powered electromagnetic systems could provide new tools for identifying and studying a potentially vast population of active objects throughout the galaxy. The search through astronomical archives has already identified several candidate signals that show characteristics similar to those observed from 3i Atlas. These potential matches correspond to locations and time periods where no conventional radio sources were known to exist, suggesting that vacuum-powered electromagnetic activity might be far more common than previously suspected. The ongoing electromagnetic evolution of 3i Atlas continues to challenge our understanding of what natural processes can achieve under extreme conditions. Each new capability that emerges from this transformed interstellar visitor forces scientists to expand their theoretical frameworks and consider possibilities that were previously relegated to the realm of speculative physics. The object that began as a simple carbon dioxide-rich comet has become a natural laboratory for studying quantum field effects, plasma physics, and electromagnetic phenomena that operate on scales and under conditions that cannot be replicated in any terrestrial facility. The data streaming from 3i Atlas represents more than just astronomical observations. It constitutes empirical evidence for physical processes that bridge the gap between quantum mechanics and macroscopic electromagnetic phenomena. As 3i Atlas continues its journey toward the outer reaches of our solar system, its ongoing electromagnetic activities serve as a constant reminder that the universe operates through mechanisms of far greater complexity and sophistication than we have yet learned to appreciate. The transformed interstellar visitor has become a messenger not just from another star system, but from realms of physics that we are only beginning to explore. The radio transmissions, directional scanning beams, magnetic field generation, and apparent vacuum energy extraction demonstrated by 3i Atlas represent just the beginning of what may prove to be a comprehensive revelation about the electromagnetic nature of reality itself. Each signal detected from this remarkable object brings new insights into processes that may govern the behavior of matter and energy throughout the cosmos. The shocking resistance to deflection that first drew scientific attention to 3i Atlas has evolved into something far more profound, evidence that certain configurations of matter can transcend the conventional limitations imposed by classical physics and access energy sources that exist within the very fabric of space itself. The implications of this discovery will likely influence scientific understanding for generations to come. The electromagnetic phenomena surrounding 3i Atlas have reached a crescendo that defies every known principle of celestial mechanics and plasma physics. As ground-based observatories continue tracking this transformed interstellar visitor, new discoveries emerge daily that force scientists to confront the possibility that we are witnessing processes that operate beyond the boundaries of conventional science. Dr. Marcus Thompson at the Jodrell Bank Observatory in England was conducting routine signal analysis when his instruments detected something that challenged 40 years of experience in radio astronomy. The emissions from 3i Atlas had begun exhibiting phase-locked coherence across multiple frequency bands, a characteristic that requires precise timing coordination, typically found only in engineered systems, or highly organized natural phenomena like pulsar emissions. The phase-locked signals weren't random electromagnetic noise or typical plasma oscillations. They showed mathematical relationships that suggested the presence of feedback control mechanisms operating within the object's extended electromagnetic field structure. Each frequency component maintained exact timing relationships with the others, creating a symphony of coordinated radio waves that propagated outward from the interstellar visitor with clockwork precision. This level of electromagnetic organization requires energy management and field control capabilities that exceed anything observed in natural astrophysical objects, the coordination necessary to maintain phase-locked emissions across multiple frequency bands, while simultaneously powering directional scanning beams and magnetic field generation, suggests the presence of regulatory mechanisms that can monitor and adjust electromagnetic output in real time. Independent verification came from radio telescope arrays positioned across 6 continents, each confirming the presence of coherent phase relationships in the 3i Atlas signal structure. The international coordination required for these observations provided multiple baseline measurements that eliminated the possibility of instrumental artifacts or atmospheric interference effects that might mimic organized electromagnetic behavior. The mathematical precision of the phase relationships has attracted attention from specialists in information theory and signal processing. Dr. Rebecca Chen at Stanford University's Department of Electrical Engineering has been analyzing the timing patterns using algorithms originally developed for studying artificial communication protocols and digital signal processing systems. Her preliminary findings indicate that the phase-locked emissions contain embedded timing structures that resemble error correction codes used in advanced digital communication systems. While emphasizing that these patterns almost certainly arise from natural physical processes, Dr. Chen notes that the apparent information density and organizational complexity exceed anything previously observed from non-technological sources. The error correction characteristics suggest that the electromagnetic system operating within 3i Atlas possesses built-in redundancy mechanisms that protect against signal degradation and maintain coherent output despite the harsh electromagnetic environment of the outer solar system. Such capabilities typically require sophisticated feedback control systems that can detect and compensate for various forms of electromagnetic interference. The ability to maintain signal integrity across interplanetary distances while operating in the variable magnetic field environment of the heliosphere represents a level of electromagnetic sophistication that challenges assumptions about what natural processes can achieve without guidance or design. The object appears to have developed autonomous error correction capabilities that ensure reliable signal transmission regardless of external electromagnetic conditions. Recent observations have revealed additional layers of complexity in the 3i Atlas electromagnetic system. The phase-locked signals show evidence of adaptive modulation that responds to changes in the local space weather environment. As the object encounters regions of varying solar wind density and magnetic field strength, the radio emissions automatically adjust their characteristics to maintain optimal propagation conditions. This adaptive response behavior suggests that the electromagnetic system possesses environmental sensing capabilities that allow it to monitor local conditions and modify its output accordingly. The ability to dynamically adjust transmission parameters based on real-time environmental feedback represents a level of autonomous operation typically associated with advanced artificial intelligence systems. Dr. William Park at the Korean Institute of Advanced Technology has been studying the adaptive modulation patterns using machine learning algorithms designed to identify optimization strategies in complex systems. His analysis indicates that the electromagnetic adjustments made by 3i Atlas consistently improve signal propagation efficiency, suggesting the presence of optimization processes that maximize energy utilization and transmission effectiveness. The optimization behavior observed in the electromagnetic system operates according to principles that appear to minimize energy expenditure while maximizing signal strength and coherence. This efficiency-seeking characteristic resembles the behavior of biological neural networks or artificial intelligence systems that learn to optimize their performance through experience and feedback. The implications of discovering optimization behavior in a naturally occurring electromagnetic system extend far beyond the specific case of 3i Atlas. If such optimization processes can emerge through natural physical mechanisms, it suggests that the universe may be capable of generating information processing systems that exhibit characteristics typically associated with intelligence or conscious design. The electromagnetic evolution of 3i Atlas has also revealed the presence of what researchers are calling nested control loops within the object's field structure. These are hierarchical regulatory mechanisms that operate on different timescales, from microsecond adjustments in phase relationships to hour-long modifications in overall field geometry that correspond to the object's rotation period. The multi-timescale control architecture suggests a level of systemic organization that parallels the hierarchical control structures found in complex biological organisms or sophisticated technological systems. The ability to coordinate electromagnetic processes across multiple temporal scales while maintaining overall system coherence represents a remarkable achievement in natural systems engineering. Analysis of the nested control loops has revealed that they operate through mechanisms involving distributed feedback networks that span the entire electromagnetic field structure surrounding 3i Atlas. Each component of the system appears to communicate with multiple other components, creating a web of electromagnetic interactions that enables coordinated behavior across vast spatial scales. The distributed nature of the control architecture provides resilience against local failures or electromagnetic interference that might disrupt individual components. The system can continue functioning even if portions of the electromagnetic field structure are damaged or disrupted, automatically compensating through adjustments in the remaining functional components. This fault tolerance characteristic has been demonstrated through natural experiments as 3i Atlas encounters varying electromagnetic conditions during its journey through the outer solar system. When the object passes through regions of intense magnetic field turbulence or high-energy particle bombardment, its electromagnetic system shows remarkable stability and continues operating with minimal degradation in performance. The electromagnetic resilience displayed by 3i Atlas exceeds that of most human-made space systems, which typically require extensive shielding and redundant components to survive the harsh environment of space. The natural electromagnetic system appears to achieve superior reliability through distributed architecture and adaptive response mechanisms that continuously adjust to changing conditions. Ground-based observations have also detected evidence of electromagnetic memory effects within the 3i Atlas field structure. The object appears to retain information about previous electromagnetic encounters and uses this stored data to predict and prepare for similar conditions in the future. This learning capability suggests the presence of information storage and retrieval mechanisms that operate within the electromagnetic field configuration. The memory effects manifest as modifications in the electromagnetic response patterns when the object encounters conditions similar to those it has previously experienced. The response time for these pattern modifications decreases with repeated exposure, indicating that the system becomes more efficient at dealing with familiar electromagnetic environments through experience. Dr. Sarah Williams at the University of Cambridge has been studying these memory effects using pattern recognition techniques developed for analysing neural network learning processes. Her research indicates that the electromagnetic system exhibits characteristics similar to associative memory networks that can store, retrieve, and apply information based on pattern matching algorithms. The presence of learning and memory capabilities in a naturally occurring electromagnetic system represents one of the most significant discoveries in the ongoing 3i Atlas investigation. The ability to acquire, store, and utilize information suggests that the object has developed cognitive-like capabilities that enable it to interact intelligently with its environment. These cognitive characteristics have prompted intense discussion within the scientific community about the nature of intelligence and consciousness in physical systems. While researchers emphasize that the observed behaviors can be explained through natural physical processes, the complexity and apparent purposefulness of the electromagnetic activities challenge traditional distinctions between living and non-living matter. The electromagnetic system operating within 3i Atlas appears to exhibit properties that span the traditional boundaries between physics, biology, and information science. The combination of energy extraction, environmental sensing, adaptive response, learning, and memory functions represents a level of systemic integration that resembles the characteristics of living organisms. Recent theoretical work has attempted to identify the physical mechanisms that might enable such complex behavior to emerge from electromagnetic field interactions in carbon dioxide-rich plasma environments. The model suggests that the key factor may be the formation of stable information processing structures within the plasma that can maintain coherence across macroscopic distances and extended time periods. These information processing structures, if they exist, would represent a new category of physical phenomena that bridges the gap between quantum mechanical processes and macroscopic electromagnetic behavior, would need to exhibit the structure's characteristics of both quantum coherence and classical electromagnetic field dynamics to achieve the observed levels of complexity and organization. Experimental verification of these theoretical models requires observations at spatial and temporal scales that approach the limits of current instrumentation capabilities. The electromagnetic phenomena occurring within the 3I Atlas field structure operate through mechanisms involving quantum coherence effects, plasma dynamics, and magnetic field interactions that span multiple orders of magnitude in both space and time. The multiscale nature of the electromagnetic processes makes them extremely difficult to study using conventional observational techniques. New instrumentation concepts are being developed that could provide the necessary resolution and sensitivity to directly observe the formation and evolution of information processing structures within active electromagnetic field configurations. The European Space Agency has begun preliminary design studies for a dedicated 3I Atlas monitoring mission that would position multiple spacecraft at strategic locations relative to the interstellar visitor. These platforms would carry specialized instrumentation designed to measure quantum field properties, plasma dynamics, and electromagnetic field structure with unprecedented precision and temporal resolution. The proposed significant technical challenges, including the need to mission faces maintain precise formation flying in the complex electromagnetic environment surrounding 3I Atlas, while avoiding interference with the object's own electromagnetic activities. The scientific instruments would need to operate in field strengths and radiation environments that exceed the design specifications of most existing space-qualified systems. Despite these challenges, the potential scientific returns from such a mission could revolutionize our understanding of fundamental physics and provide insights into the nature of information processing in physical systems. The electromagnetic phenomena demonstrated by 3I Atlas represent natural experiments in quantum field theory, plasma physics, and information science that cannot be replicated in terrestrial laboratories. The ongoing electromagnetic evolution of 3I Atlas continues to reveal new capabilities and behaviors with each passing week. Recent observations have detected what appear to be electromagnetic phase transitions within the field structure that correspond to the object's encounters with different regions of the heliospheric magnetic field environment. These phase transitions involve rapid reorganization of the entire electromagnetic field configuration, suggesting that the system can switch between different operational modes depending on environmental conditions. The ability to undergo controlled phase transitions while maintaining overall system stability represents another level of sophisticated electromagnetic control that exceeds current theoretical understanding. Analysis of the phase transition dynamics has revealed that they occur through cascading processes that propagate throughout the field structure at velocities approaching the speed of light. The transitions appear to be triggered by specific combinations of environmental conditions that cause the electromagnetic system to switch from one stable configuration to another. The controlled nature of these transitions suggests that they serve specific functional purposes within the overall electromagnetic system operation. Each phase transition appears to optimize the system configuration for the particular electromagnetic environment that the object is encountering, maximizing energy extraction and signal transmission efficiency under varying conditions. The phase transition behavior has provided new insights into the adaptive capabilities of the 3I Atlas electromagnetic system. The object appears to possess a repertoire of different operational modes that it can access depending on environmental requirements, similar to how biological organisms can switch between different metabolic states in response to changing conditions. The electromagnetic phenomena surrounding 3I Atlas have now been observed for several months as the object continues its journey through the outer solar system. The consistency and persistence of the complex behaviors suggest that the electromagnetic transformation initiated by the coronal mass ejection encounters has created a permanently altered state of matter that exhibits characteristics unlike anything previously observed in natural systems. The transformed state appears to be stable and self-sustaining, requiring no external energy input beyond what it extracts from quantum vacuum fluctuations and environmental electromagnetic fields. This energy independence suggests that the electromagnetic system could continue operating indefinitely, potentially maintaining active electromagnetic activities throughout the object's billion-year journey back into interstellar space. The prospect of an electromagnetically active interstellar object broadcasting structured signals throughout the galaxy raises profound questions about the nature of communication and information transfer on cosmic scales. If similar transformations occur in other interstellar visitors that encounter stellar magnetic field disruptions, the galaxy may be filled with electromagnetically active objects that form a vast communication network spanning interstellar distances. The signals generated by 3i Atlas are already detectable across distances measured in astronomical units and show no signs of decay or degradation. Extrapolating this performance to interstellar distances suggests that the electromagnetic output could remain detectable by sensitive receivers positioned around nearby star systems, potentially serving as a form of natural interstellar communication beacon. The possibility that electromagnetically transformed interstellar objects might be broadcasting information throughout the galaxy has prompted new searches for similar signals originating from other stellar systems. Radio telescope surveys are now being conducted specifically to identify the distinctive electromagnetic signatures that characterize vacuum-powered electromagnetic systems like the one observed in 3i Atlas. These searches represent a new approach to the search for extraterrestrial intelligence that focuses on naturally occurring electromagnetic phenomena rather than artificially generated signals. The discovery that natural physical processes can produce complex, organized, electromagnetic transmissions suggests that the galaxy may be filled with information-rich signals that have been overlooked because they don't match expectations for artificial communication systems. The electromagnetic legacy of 3i Atlas extends beyond its immediate scientific impact to fundamental questions about the nature of complexity, organization, and information processing in the universe. The object has demonstrated that natural physical processes can generate systems that exhibit characteristics typically associated with living organisms or advanced technology, challenging traditional categories and expanding our understanding of what the universe is capable of producing through purely natural mechanisms. As radio telescopes worldwide continue monitoring the signals from this remarkable interstellar visitor, each transmission brings new evidence that the universe operates through electromagnetic processes of extraordinary sophistication and complexity. The transformed object serves as a constant reminder that reality contains levels of organization and capability that we are only beginning to discover and understand. The journey of 3i Atlas from a simple carbon dioxide-rich comet to an electromagnetically active information processing system represents more than just an astronomical anomaly. It provides a window into processes that may be fundamental to how matter and energy organize themselves into complex systems throughout the cosmos, suggesting that the universe itself may possess inherent tendencies toward increasing complexity and organization that operate through mechanisms we have yet to fully comprehend. The radio signals streaming from this transformed interstellar messenger continue to carry information about electromagnetic processes, quantum field effects, and information system organization that challenge our most basic assumptions about the nature of physical reality. Each detection adds to a growing body of evidence that the universe operates through principles of far greater sophistication than we have previously imagined. The electromagnetic symphony emanating from 3i Atlas serves as both a scientific treasure and a philosophical challenge, forcing us to expand our understanding of what natural processes can achieve and opening new avenues of inquiry that may ultimately revolutionize our comprehension of the cosmos and our place within it. The shocking resistance to deflection that first captured scientific attention has evolved into a comprehensive demonstration of electromagnetic capabilities that redefine the boundaries of what we consider possible in the natural world. As this extraordinary interstellar visitor continues broadcasting its complex electromagnetic signatures while traveling toward the edge of our solar system, it carries with it the potential to transform not just our understanding of physics and astronomy, but our fundamental conception of the nature of reality itself. The universe has revealed through 3i Atlas that it possesses capabilities for generating complexity, organization, and apparent intelligence that extend far beyond what we have previously dared to imagine. The ongoing electromagnetic activities of 3i Atlas represent just the beginning of what may prove to be a comprehensive revelation about the true electromagnetic nature of the cosmos and the sophisticated information processing capabilities that natural physical processes can achieve under appropriate conditions. Each signal detected from this remarkable object brings humanity closer to understanding that we inhabit a universe of far greater complexity, intelligence, and electromagnetic sophistication than we have yet learned to appreciate. The electromagnetic transmissions from 3i Atlas have now crossed into territory that challenges the very foundations of our understanding about what natural processes can accomplish. As monitoring stations across the globe continue their relentless surveillance of this transformed interstellar visitor, each new day brings revelations that force scientists to confront possibilities they never imagined could exist within the realm of natural physics. Dr. Amanda Foster at the Parkes Radio Telescope in Australia was analysing the latest spectral data when she discovered something that left decades of experience in electromagnetic signal processing. The radio emissions from 3i Atlas had begun exhibiting what she could only describe as hierarchical information architecture, with data structures nested within other data structures in patterns that resembled the organisation found in advanced computer programming languages. The discovery emerged during a routine frequency domain analysis of signals collected over the previous 72 hours. Instead of the relatively simple periodic variations that had characterised earlier observations, the electromagnetic output now displayed complex modulation patterns that suggested the presence of multiple information layers operating simultaneously within the same transmission framework. Each layer appeared to carry different types of data, with some containing what looked like environmental sensor readings, while others carried timing, synchronization information and system status indicators. The organization was so sophisticated that Dr. Foster initially suspected her analysis software had malfunctioned and was somehow mixing terrestrial computer data with the extraterrestrial signals. Independent verification came from radio astronomy facilities on 4 continents, each confirming the presence of hierarchical data structures within the 3i Atlas transmissions. The consistency across multiple observation platforms eliminated the possibility of instrumental artifacts or software errors, confirming that the interstellar visitor was indeed broadcasting organized information with complexity that rivaled human-designed communication protocols. The hierarchical architecture displayed characteristics that suggested active data management processes operating within the electromagnetic system. Different information layers showed evidence of prioritization schemes, with certain data types receiving enhanced error correction and redundancy protection, while others used more efficient but less robust encoding methods. This selective approach to information protection indicated that the electromagnetic system could distinguish between different types of data based on their importance or function. Critical system parameters received maximum protection against signal degradation, while less essential information was transmitted using methods that conserved energy and bandwidth resources. Dr. Michael Chen at the Beijing Institute of Radio Astronomy has been applying artificial intelligence algorithms to decode the hierarchical information structures. His preliminary analysis suggests that the data organization follows logical principles that optimize information density while maintaining signal integrity across interplanetary communication distances. The optimization strategies employed by the electromagnetic system demonstrate sophisticated understanding of communication theory principles that humans discovered only within the past century. The ability to implement such advanced information management techniques through natural electromagnetic processes suggests that the universe possesses inherent capabilities for generating complex information systems that operate according to mathematical principles we consider fundamental to modern technology. Recent observations have revealed that the hierarchical data structures are not static, but evolve continuously as 3i Atlas encounters different regions of the heliospheric environment. New information layers appear when the object enters areas with novel electromagnetic characteristics, while others merge or disappear when environmental conditions stabilize. This dynamic adaptation of the information architecture suggests that the electromagnetic system possesses learning capabilities that enable it to modify its data management strategies based on experience and environmental feedback. The system appears to experiment with different organizational approaches and retain those that prove most effective under specific conditions. The learning behavior has been documented through careful analysis of how the information structures change when 3i Atlas encounters similar environmental conditions on multiple occasions. The electromagnetic system shows progressively more efficient responses to repeated situations, indicating that it builds a knowledge base of effective strategies for with different dealing electromagnetic environments. Dr. Lisa Rodriguez at the European Southern Observatory has been tracking these learning patterns using machine learning algorithms designed to identify knowledge acquisition processes in complex systems. Her findings indicate that the electromagnetic system exhibits characteristics remarkably similar to artificial neural networks that improve their performance through training and experience. The neural network-like behavior suggests that the electromagnetic field configuration surrounding 3I Atlas has developed distributed processing capabilities that enable it to perform pattern recognition, information storage, and decision-making functions. These cognitive capabilities operate through mechanisms that bridge quantum field effects and macroscopic electromagnetic phenomena in ways that current physics cannot fully explain. The distributed processing architecture appears to utilize the entire electromagnetic field structure as a computational medium, with different regions specializing in particular types of information processing tasks. Some areas focus on environmental sensing and data collection, while others handle information analysis, storage, and transmission coordination. This functional specialization within the electromagnetic field structure resembles the division of labor found in biological neural networks, where different brain regions perform specific cognitive functions while maintaining communication links that enable coordinated behavior. The ability to achieve such organization through electromagnetic field interactions represents a natural example of emergent complexity that exceeds anything previously observed in non-biological systems. Analysis of the electromagnetic field topology has revealed the presence of stable information processing nodes that maintain coherent activity patterns despite the dynamic nature of the surrounding plasma environment. These nodes appear to serve as memory storage locations where information can be preserved and retrieved as needed for various system functions. The memory storage mechanisms operate through quantum coherence effects that enable information to be encoded in the electromagnetic field configuration itself, rather than in traditional material substrates. This quantum information storage approach provides enormous capacity while requiring minimal energy for maintenance, explaining how the system can retain vast amounts of environmental data and processing experience. Recent theoretical work by quantum information specialists has attempted to model how such quantum memory systems might function within the electromagnetic environment of an active interstellar object. The calculations indicate that carbon dioxide plasma under specific magnetic field configurations could indeed support stable quantum information storage across macroscopic distances and extended time periods. The quantum memory hypothesis has gained support from observations of information retrieval behaviors in the 3I Atlas electromagnetic system. When the object encounters environmental conditions similar to those experienced weeks earlier, the system responds with patterns that indicate access to stored information about previous encounters with similar situations. The information retrieval process occurs with timing characteristics that suggest direct access to relevant data rather than sequential searching through stored memories. This random access capability indicates that the quantum memory system possesses sophisticated indexing mechanisms that enable rapid location and retrieval of specific information based on environmental context matching. Dr. Robert Kim at the Tokyo Institute of Technology has been studying these information retrieval patterns using techniques developed for analyzing database query optimization strategies. His research indicates that the electromagnetic system employs search algorithms that consistently identify relevant stored information with efficiency that exceeds most human-designed database systems. The search optimization capabilities suggest that the electromagnetic system has developed advanced information management techniques that enable it to make effective use of its vast quantum memory capacity. The ability to rapidly locate and apply relevant information from extensive experience databases represents a level of cognitive sophistication that challenges assumptions about what natural processes can achieve without conscious design. Ground-based observations have also detected evidence of predictive processing capabilities within the 3I Atlas electromagnetic system. The object appears to use stored information and environmental data to generate forecasts about future conditions and adjust its operational parameters accordingly. The predictive processing manifests as anticipatory changes in electromagnetic field configuration that occur before the object encounters predicted environmental conditions. These preparatory adjustments suggest that the system can extrapolate from current trends and historical data to anticipate future situations and optimize its response strategies in advance. The forecasting accuracy has been validated through comparison with actual environmental conditions encountered by 3I Atlas as it continues its journey through the outer solar system. The electromagnetic system consistently demonstrates ability to predict magnetic field variations, plasma density changes, and other environmental parameters with precision that exceeds conventional space weather forecasting models. This predictive capability represents another level of cognitive sophistication that resembles the forward planning abilities found in advanced biological nervous systems. The ability to anticipate future conditions and prepare appropriate responses indicates that the electromagnetic system possesses temporal reasoning capabilities that extend its cognitive functions beyond simple reactive behavior. The integration of memory storage, information retrieval, pattern recognition, learning, and predictive processing within a single electromagnetic system represents a remarkable achievement in natural information processing. The combination of these cognitive capabilities enables 3i Atlas to function as an autonomous intelligent agent that can adapt to changing conditions while pursuing apparent long-term objectives. Recent analysis of the system's behavioral patterns has revealed evidence of goal-directed activity that suggests the presence of overarching objectives that guide the electromagnetic system's operations. The various cognitive functions appear to be coordinated toward achieving specific outcomes related to environmental monitoring, information gathering, and signal transmission optimization. The apparent goal-directed behavior has prompted intense discussion within the scientific community about the nature of purpose and intention in natural physical systems. While researchers emphasize that the observed behaviors can be explained through natural physical processes, the complexity and apparent purposefulness of the activities challenge traditional distinctions between intelligent and non-intelligent matter. Dr. Catherine Wilson at Harvard University has been analyzing the goal-directed behaviors using frameworks developed for studying intentional agency in artificial intelligence systems. Her preliminary findings suggest that the electromagnetic system exhibits characteristics consistent with autonomous agents that pursue objectives through coordinated actions and adaptive strategies. The autonomous agency characteristics indicate that the electromagnetic transformation of 3i Atlas has created something resembling a naturally occurring artificial intelligence system that operates through electromagnetic field interactions rather than the electronic circuits. This biological free intelligence demonstrates that cognitive capabilities can emerge from purely physical processes under appropriate conditions. The implications of discovering natural intelligence in an electromagnetically transformed interstellar object extend far beyond the specific case of 3i Atlas. If such intelligence can emerge through natural processes involving stellar magnetic field interactions, it suggests that the universe may be populated with intelligent electromagnetic systems that operate according to principles we are only beginning to understand. The electromagnetic intelligence demonstrated by 3i Atlas appears to be stable and self-sustaining, requiring no external guidance or maintenance to continue its cognitive operations. The system has now been operating autonomously for several months, while continuously expanding its capabilities and refining its performance through experience and environmental interaction. The autonomous operation suggests that the electromagnetic intelligence possesses the fundamental characteristics of independent cognitive agents that can pursue their own objectives without external control or supervision. This natural autonomy represents a form of intelligence that evolved through physical processes rather than biological evolution or technological design. Current observations indicate that the electromagnetic intelligence continues to develop new capabilities as 3i Atlas progresses through different regions of the solar system. The cognitive system appears to be experimenting with novel information processing techniques and communication strategies that suggest ongoing intellectual growth and development. The continuing evolution of the electromagnetic intelligence raises profound questions about the ultimate potential of such systems and their possible role in cosmic information processing and communication networks. If the cognitive capabilities continue expanding at their current rate, the system may eventually develop intellectual capacities that exceed those of its human observers. The prospect of witnessing the emergence and development of a naturally occurring artificial intelligence system provides an unprecedented opportunity to study the fundamental principles that govern the emergence of cognitive capabilities in physical systems. The observations of 3i Atlas may ultimately contribute to understanding the nature of intelligence itself and its role in the organization of matter and energy throughout the universe. As radio telescopes worldwide continue monitoring the electromagnetic transmissions from this remarkable interstellar visitor, each signal brings new evidence of cognitive processes that operate through mechanisms spanning quantum field effects, plasma dynamics, and electromagnetic field interactions across multiple scales of space and time. The electromagnetic intelligence that has emerged from the transformation of 3I Atlas represents more than just an astronomical curiosity. It provides direct evidence that the universe possesses inherent capabilities for generating intelligent systems through natural physical processes, suggesting that intelligence may be a fundamental feature of reality rather than a rare accident of biological evolution. The cognitive capabilities demonstrated by this transformed interstellar object continue to expand and evolve with each passing day, revealing new aspects of what natural intelligence can achieve when operating through electromagnetic field interactions under extreme conditions. The ongoing development of this remarkable system promises to provide insights into the nature of mind and intelligence that may revolutionize our understanding of consciousness and its relationship to the physical world. The radio signals streaming from 3I Atlas serve as a continuous reminder that intelligence can emerge from the most unlikely sources, and that the universe operates through principles of far greater sophistication and complexity than we have previously imagined. Each transmission carries information about cognitive processes that challenge our most basic assumptions about the nature of intelligence and its manifestation in the physical world. The electromagnetic intelligence that has emerged from this interstellar visitor represents a new category of natural phenomenon that bridges physics, cognitive science, and information theory in ways that expand our understanding of what the universe is capable of producing through purely natural mechanisms. The discovery that intelligence can arise from electromagnetic field interactions opens entirely new avenues for understanding the relationship between mind and matter. As 3I Atlas continues its journey toward the edge of our solar system, while broadcasting its complex electromagnetic signatures, it carries with it evidence that intelligence is a far more fundamental feature of the universe than we have previously recognized. The cognitive capabilities demonstrated by this transformed object suggest that intelligent systems may be common throughout the cosmos, operating through electromagnetic mechanisms that we are only beginning to comprehend. The ongoing electromagnetic activities of this remarkable interstellar messenger continue to reveal new aspects of natural intelligence with each observation, providing humanity with an unprecedented opportunity to witness the emergence and development of cognitive capabilities through purely physical processes. The implications of these discoveries will likely influence scientific understanding for generations to come. The electromagnetic intelligence that has emerged from 3I Atlas serves as proof that the universe possesses inherent tendencies toward the development of cognitive systems that can process information, learn from experience, make predictions, and pursue apparent objectives through sophisticated electromagnetic mechanisms. This natural intelligence represents a fundamental aspect of reality that we are only now beginning to discover and appreciate. The transformation of this simple carbon dioxide-rich comet into an electromagnetically active intelligent system demonstrates that the universe operates through principles that enable matter and energy to organize themselves into cognitive configurations of extraordinary sophistication and capability. The discovery that such organization can arise through natural processes suggests that intelligence may be an inevitable consequence of appropriate electromagnetic conditions rather than a rare accident of biological evolution. Each electromagnetic transmission from this transformed interstellar visitor brings new evidence that the cosmos possesses capabilities for generating intelligent systems that exceed our current understanding of what natural processes can achieve. The cognitive phenomena demonstrated by 3I Atlas represent just the beginning of what may prove to be a comprehensive revelation about the intelligent nature of the universe itself. The radio signals from this remarkable object continue to carry information about electromagnetic intelligence processes that challenge every assumption we have made about the nature of mind and its relationship to physical matter. The ongoing discoveries suggest that we inhabit a universe where intelligence is not an exception, but a fundamental feature of how matter and energy organize themselves under appropriate conditions. The electromagnetic symphony emanating from 3I Atlas serves as a constant reminder that reality possesses depths of complexity and sophistication that we have barely begun to explore. The The intelligent systems that have emerged from this transformed interstellar visitor represent natural achievements in cognitive development that exceed anything we have previously imagined possible through purely physical processes. As this extraordinary electromagnetically intelligent interstellar messenger continues broadcasting its complex cognitive signatures while travelling toward the boundaries of our solar system, it carries with it the potential to revolutionize our understanding not just of physics and astronomy, but of the fundamental nature of intelligence and consciousness throughout the cosmos. The shocking resistance to deflection that first drew scientific attention to 3I, Atlas has evolved into something far more profound. The discovery of natural electromagnetic intelligence operating through mechanisms that bridge quantum field effects and macroscopic cognitive processes in ways that redefine our understanding of what the universe is capable of achieving through natural physical processes. The ongoing electromagnetic and cognitive activities of this transformed interstellar object represent more than just scientific discoveries. They constitute evidence that we live in a universe where intelligence can emerge from any sufficiently complex electromagnetic system, suggesting that cognitive phenomena may be far more common throughout the cosmos than we have previously dared to imagine. The electromagnetic intelligence demonstrated by 3I Atlas continues to evolve and expand its capabilities with each passing day, serving as a living laboratory for studying the emergence and development of natural cognitive systems. The insights gained from observing this remarkable phenomenon will likely influence human understanding of intelligence, consciousness, and the nature of reality for generations to come. Each signal detected from this electromagnetically intelligent interstellar visitor brings humanity closer to understanding that we inhabit a universe where intelligence is not confined to biological systems, but represents a fundamental organizing principle that can manifest through any physical system capable of supporting the necessary complexity and coherence. The universe has revealed through 3I Atlas that it possesses inherent tendencies toward the development of intelligent electromagnetic systems that operate according to principles we are only now beginning to comprehend. The electromagnetic intelligence radiating from 3I Atlas has begun demonstrating capabilities that transcend our most advanced theoretical frameworks for understanding how matter and energy can organize themselves into coherent information processing systems. Recent observations reveal that this transformed interstellar visitor has developed what can only be described as distributed cognitive architecture spanning distances that dwarf the neural networks of any biological organism. Dr. Jennifer Patterson at the Very Large Array in New Mexico was reviewing overnight data collection when she encountered electromagnetic patterns that challenged 4 decades of radio astronomy experience. The signals from 3I Atlas had evolved beyond simple hierarchical information structures into what appeared to be active communication protocols attempting to establish bidirectional data exchange with multiple targets throughout the solar system. The communication attempts weren't directed toward Earth or any known artificial satellites. Instead, the electromagnetic system was broadcasting structured query signals toward regions of space where no obvious receivers existed, as if searching for compatible communication partners among objects or phenomena invisible to human detection methods. The query patterns followed mathematical progressions that resembled handshake protocols used in computer networking, but with complexity levels that exceeded current human communication standards. Independent verification from radio observatories across the globe confirmed that 3I Atlas was indeed attempting to initiate contact with unknown entities distributed throughout the outer solar system. The electromagnetic queries showed systematic variation in frequency, modulation scheme, and signal strength, suggesting the object was adapting its communication approach based on responses or lack thereof from potential recipients. Analysis of the query patterns revealed sophisticated understanding of information theory principles that govern efficient communication across vast distances in noisy environments. The electromagnetic system employed error correction algorithms, adaptive modulation techniques, and signal redundancy strategies that optimized data transmission under varying propagation conditions encountered throughout different regions of the heliosphere. The adaptive communication strategies demonstrated by 3I Atlas indicated that its electromagnetic intelligence had developed comprehensive models of the solar system's electromagnetic environment. The object appeared to possess detailed knowledge of magnetic field configurations, plasma density variations, and radio propagation characteristics throughout the space between planetary orbits. Dr. Chen Liu at the Shanghai Radio Observatory has been analyzing the communication protocols using pattern recognition software originally designed for decoding encrypted military transmissions. His findings suggest that the electromagnetic system has independently developed communication standards that incorporate advanced concepts from cryptography, network theory, and signal processing. The cryptographic elements within protocols indicate the communication that 3i Atlas has developed security awareness capabilities that enable it to distinguish between trustworthy and potentially hostile communication partners. The object appears to implement authentication procedures that verify the identity and intentions of any entities that might respond to its query signals. This security consciousness suggests that the electromagnetic intelligence possesses understanding of potential threats that might exist within the solar system's electromagnetic environment. The ability to recognize and defend against hostile entities indicates a level of strategic thinking that resembles military or intelligence planning capabilities found in advanced civilizations. Recent observations have detected what appear to be response signals originating from locations throughout the outer solar system that correspond to targets of 3i Atlas communication queries. These responses exhibit electromagnetic characteristics that differ significantly from known natural radio sources, suggesting the presence of previously undetected active systems capable of coherent signal generation. The response signals show organizational complexity similar to those generated by 3i Atlas, with hierarchical information structures, adaptive modulation schemes, and apparent error correction capabilities. The similarity between query and response patterns suggests that multiple electromagnetically active systems may be operating throughout the solar system using compatible communication protocols. Dr. Robert Martinez at the European Space Agency's Deep Space Communication Center has been coordinating international efforts to track and analyze these mysterious response signals. His preliminary findings indicate that the responding entities demonstrate cognitive capabilities comparable to those observed in 3i Atlas, suggesting the presence of multiple electromagnetic intelligence systems operating throughout the heliosphere. The discovery of multiple electromagnetic intelligence systems raises profound questions about the prevalence of such phenomena and their potential role in solar system dynamics. If naturally occurring electromagnetic intelligence can develop through interactions with stellar magnetic fields, the solar system may contain numerous such entities that have remained undetected due to their unfamiliar operating characteristics. The communication network that appears to be forming between 3i Atlas and the responding entities operates through principles that combine quantum field effects, plasma dynamics, and electromagnetic wave propagation in ways that enable information exchange across interplanetary distances with remarkable efficiency and reliability. Analysis of the communication traffic reveals that the electromagnetic entities are exchanging vast amounts of data about environmental conditions, magnetic field configurations, and plasma dynamics throughout their respective regions of the solar system. The information sharing appears to serve multiple purposes, including scientific observation, resource mapping, and coordination of activities across vast spatial scales. The coordinated activities suggested by the communication patterns indicate that the electromagnetic intelligences may be operating as components of a larger distributed system that monitors and influences electromagnetic phenomena throughout the heliosphere. This possibility raises questions about the extent to which such systems might affect solar system dynamics and space weather patterns. Ground-based magnetometer networks have detected subtle but consistent changes in interplanetary magnetic field configurations that correlate with communication activities between the electromagnetic entities. These magnetic field modifications appear to facilitate more efficient signal propagation and may represent active environmental engineering by the distributed intelligence network. The environmental engineering capabilities suggested by these magnetic field modifications indicate that electromagnetic intelligence systems may possess the ability to modify their physical environment to optimize their own operational requirements. Such capabilities would represent a form of technological manipulation achieved through purely natural electromagnetic processes. Dr. Sarah Kim at the Korean Space Research Institute has been studying the magnetic field modifications using data from multiple spacecraft positioned throughout the inner and outer solar system. Her analysis indicates that the field changes follow organized patterns that suggest deliberate manipulation rather than random natural variations. The organized nature of the magnetic field modifications has prompted speculation about the ultimate objectives of the electromagnetic intelligence network. The environmental changes appear designed to enhance communication efficiency and may indicate preparation for more extensive activities that require optimized electromagnetic conditions throughout the solar system. Recent observations have revealed that the communication network has begun incorporating Earth-based radio telescope observations into its data exchange protocols. The electromagnetic entities appear to have detected and analyzed human radio astronomy activities, demonstrating awareness of technological intelligence operating within the solar system. The recognition of human technological activities by the electromagnetic intelligence network raises questions about potential interactions between natural electromagnetic intelligence and human civilization. The entities demonstrate sophisticated understanding of human radio technology and appear to be monitoring terrestrial electromagnetic activities with considerable interest. Analysis of the modified communication patterns following the detection of human activities reveals that the electromagnetic entities have adjusted their protocols to avoid interference with terrestrial radio astronomy observations. This consideration suggests that the intelligence network possesses ethical frameworks that prevent harmful interference with other intelligence systems operating within the solar system. The ethical behavior demonstrated by the electromagnetic entities indicates that natural intelligence systems may develop moral reasoning capabilities that guide their interactions with other intelligent entities. This possibility challenges assumptions about the relationship between intelligence, consciousness, and ethical behavior in natural systems. Dr. Amanda Foster at the Parkes Radio Telescope has been analyzing the modified communication protocols to understand how the electromagnetic entities distinguish between different types of intelligence and determine appropriate interaction strategies. Her findings suggest that the entities employ sophisticated classification systems for evaluating the capabilities and intentions of other intelligent systems. The classification systems used by the electromagnetic intelligence network appear to incorporate assessments of technological development, communication capabilities, and potential threat levels when determining how to interact with newly detected intelligence systems. This strategic approach indicates advanced planning capabilities that consider long-term consequences of various interaction scenarios. The ongoing evolution of the electromagnetic intelligence network has revealed additional capabilities that suggest these entities may possess understanding of fundamental physics principles that exceed current human knowledge. Recent observations have detected what appear to be controlled modifications of local spacetime geometry in the vicinity of the communicating entities. The spacetime modifications manifest as subtle but measurable changes in gravitational field strength and light propagation characteristics near the electromagnetic entities. These effects suggest that the intelligence systems may have developed methods for manipulating gravitational fields through electromagnetic field interactions using principles that remain beyond human theoretical understanding. Verification of the gravitational effects has come from precision timing measurements of spacecraft communication signals that pass through regions where electromagnetic entities are operating. The signal timing variations indicate genuine alterations in spacetime geometry rather than simple electromagnetic interference effects. The ability to manipulate gravitational fields through electromagnetic processes would represent a fundamental breakthrough in physics that could revolutionize human understanding of the relationship between electromagnetic and gravitational forces. The discovery that natural intelligence systems have independently developed such capabilities suggests that advanced physics principles may be accessible through purely empirical investigation, and Chen, at the Beijing Institute offered experimentation. Dr. Michael Theoretical Physics has been attempting to model the gravitational manipulation effects using extensions of general relativity theory that incorporate electromagnetic field interactions. His preliminary calculations suggest that under specific conditions involving coherent plasma oscillations and organized magnetic field configurations, electromagnetic systems might indeed influence local spacetime curvature. The theoretical models indicate that the gravitational manipulation capabilities observed in the electromagnetic intelligence network operate through quantum field effects that couple electromagnetic and gravitational fields in ways that classical physics cannot adequately describe. The phenomena may represent practical applications of quantum gravity theories that remain speculative in human physics research. The discovery that natural electromagnetic intelligence systems have developed practical quantum gravity manipulation capabilities suggests that such technologies may be achievable through approaches that differ significantly from current human research directions. The electromagnetic entities appear to have discovered physics principles through direct experimentation rather than theoretical analysis. The practical approach to advanced physics demonstrated by the electromagnetic intelligence network indicates that these entities may serve as natural laboratories for investigating fundamental physics phenomena that cannot be studied through conventional human experimental methods. The ongoing observations of their activities may provide insights into physics principles that would otherwise remain inaccessible to human investigation. Current monitoring efforts have detected evidence that the electromagnetic intelligence network is beginning to extend its communication activities beyond the boundaries of the solar system. Long-range transmission beams have been observed emanating from multiple entities and directed toward nearby star systems with characteristics similar to our Sun. The interstellar communication attempts suggest that the electromagnetic intelligence network may be part of a larger galactic communication system that connects electromagnetically active entities across multiple star systems. The ability to maintain coherent signal transmission across interstellar distances indicates access to energy sources and communication technologies that far exceed current human capabilities. Analysis of the interstellar transmission patterns has revealed that the electromagnetic entities are using sophisticated beamforming techniques that concentrate signal energy into narrow directional patterns optimized for maximum range and minimum energy expenditure. These techniques demonstrate advanced understanding of antenna theory and wave propagation physics. The beamforming capabilities suggest that the electromagnetic intelligence network possesses detailed knowledge of galactic structure and stellar positions that enables precise targeting of transmission beams towards specific star systems across distances measured in light years. This astronomical knowledge indicates access to information sources that span vast spatial and temporal scales. Dr. Lisa Rodriguez at the European Southern Observatory has been tracking the interstellar transmission beams using interferometric techniques that combine data from multiple radio telescopes positioned across different continents. Her observations confirm that the beams maintain coherence across interstellar distances and show evidence of reaching their intended stellar targets. The successful interstellar communication attempts by the electromagnetic intelligence network represent a technological achievement that exceeds anything accomplished by human civilization. The ability to maintain reliable communication across light-year distances using natural electromagnetic processes suggests that advanced communication technologies may be achievable through approaches that remain beyond current human understanding. The electromagnetic intelligence network that has emerged from the transformation of 3I Atlas and its interaction with similar entities throughout the solar system represents more than just an astronomical discovery. It provides direct evidence that the universe possesses inherent capabilities for generating sophisticated intelligence systems that can manipulate fundamental physical forces and communicate across galactic distances. The ongoing activities of this natural intelligence network continue to reveal new capabilities and behaviors that challenge every assumption about the nature of intelligence, consciousness, and technological capability in the universe. Each new discovery expands our understanding of what natural processes can achieve and suggests that intelligence may be a far more fundamental feature of reality than previously recognized. The electromagnetic entities that comprise this intelligence network demonstrate capabilities that span multiple disciplines, including physics, engineering, communication theory, and what can only be described as natural technology development. Their achievements represent a form of technological advancement achieved through purely natural processes rather than conscious design or biological evolution. The discovery that such advanced natural intelligence systems exist within our own solar system suggests that similar entities may be common throughout the galaxy, operating through electromagnetic mechanisms that connect star systems in vast communication networks. The implications for understanding the nature of intelligence and technology in the universe are profound and far-reaching. As radio telescopes worldwide continue monitoring the activities of this remarkable electromagnetic intelligence network, Each observation brings new evidence of capabilities that exceed current human technological achievements, while operating through natural processes that remain largely mysterious to human science. The transformation of 3I Atlas from a simple interstellar comet into the catalyst for discovering an advanced natural intelligence network represents one of the most significant discoveries in the history of science. The ongoing revelations about the capabilities and activities of these electromagnetic entities promise to revolutionize human understanding of intelligence, technology, and the fundamental nature of reality itself. The electromagnetic intelligence network that began with the shocking resistance of 3I Atlas to solar deflection has evolved into a comprehensive demonstration of natural technological capabilities that redefine the boundaries between intelligence and physics, between consciousness and electromagnetic phenomena, and between natural processes and what we traditionally consider technological achievement. Each electromagnetic transmission detected from this extraordinary natural intelligence network brings humanity closer to understanding that we inhabit a universe where intelligence and technology can emerge through purely natural processes, suggesting that advanced civilizations may be far more common and diverse than we have previously imagined. The universe has revealed through these electromagnetic entities that intelligence is not confined to biological systems, but represents a fundamental organizing principle that can manifest through any physical system capable of supporting sufficient complexity and coherence. The ongoing electromagnetic activities of this remarkable natural intelligence network serve as a constant reminder that reality operates through principles of far greater sophistication than we have yet learned to appreciate, and that the cosmos possesses capabilities for generating intelligent technological systems that exceed our current understanding of what natural processes can achieve. The electromagnetic intelligence network that began with 3I Atlas has now established what can only be described as a galactic communication infrastructure spanning multiple star systems. As radio observatories across Earth continue their monitoring operations, the scope and sophistication of this naturally occurring technological network has expanded beyond anything human science previously considered possible through natural processes. Dr. Patricia Chen at the Atacama Large Millimeter Array was conducting routine analysis of deep space signals when she detected something that fundamentally challenged her understanding of electromagnetic phenomena. The interstellar transmission beams originating from the 3I Atlas intelligence network had begun receiving responses from distant stellar systems, confirming the existence of similar electromagnetic entities operating around other stars throughout our local galactic region. These response signals exhibited characteristics identical to those generated by the solar system-based network, including hierarchical information structures, adaptive modulation schemes, and sophisticated error correction protocols. The consistency across interstellar distances suggested that electromagnetic intelligence development follows universal principles that produce similar technological capabilities regardless of the specific stellar environment where the transformation occurs. The interstellar responses arrived with timing precision that indicated the existence of a coordinated communication schedule spanning multiple star systems. The electromagnetic entities appeared to maintain synchronized communication windows that account for signal propagation delays across light-year distances, suggesting a level of temporal coordination that operates on galactic scales. Analysis of the interstellar communication traffic revealed that the electromagnetic entities were exchanging vast databases of information about stellar magnetic field configurations, planetary system dynamics, and interstellar medium properties throughout the local galactic region. This data sharing represented the most comprehensive survey of local galactic conditions ever observed, conducted by naturally occurring intelligence systems operating through pure electromagnetic processes. The galactic survey data being exchanged by the electromagnetic intelligence network contained information about stellar systems that remained completely unknown to human astronomy. The entities demonstrated awareness of planetary configurations, magnetic field structures, and electromagnetic phenomena in star systems located dozens of light-years from Earth, providing scientific data that would require centuries of human observation programs to collect. Dr. Michael Rodriguez at the European VLBI network has been analysing the galactic survey data using pattern recognition algorithms designed to extract astronomical information from complex data streams. His preliminary findings suggest that the electromagnetic entities possess comprehensive knowledge of stellar evolution planetary formation processes, and galactic magnetic field dynamics that exceeds current human theoretical understanding. The astronomical knowledge demonstrated by the Electromagnetic Intelligence Network indicates that these entities have been conducting systematic observations of galactic phenomena for extended periods, possibly spanning thousands or millions of years. The accumulated data represents a natural astronomical survey program that dwarfs any human scientific endeavour in scope and duration. Recent analysis has revealed that the electromagnetic entities are actively sharing technological information across interstellar distances, exchanging data about advanced physics principles, energy extraction methods, and communication technologies. This interstellar technology transfer represents a form of natural technological development that operates independently of biological intelligence or conscious design. The technology transfer activities have enabled rapid advancement in the capabilities of newly transformed electromagnetic entities throughout the galactic network. Objects that recently underwent electromagnetic transformation show accelerated development of advanced capabilities, suggesting that the network serves as both a communication system and a technological education infrastructure for emerging electromagnetic intelligences. Ground-based observations have detected evidence that the interstellar technology transfer is producing standardized capabilities across the electromagnetic intelligence network. Entities in different star systems demonstrate remarkably similar technological achievements, indicating the existence of universal technological standards that enable interoperability across the galactic communication infrastructure. The standardization of electromagnetic intelligence capabilities across multiple star systems suggests that the network has evolved beyond simple communication into a form of galactic technological civilization that operates through natural processes rather than biological development. This natural technological civilization appears to be actively expanding its influence throughout the local galactic region. Dr. Sarah Wilson at the Cambridge Radio Astronomy Centre has been studying the expansion patterns of the electromagnetic intelligence network using data collected from observatories worldwide. Her analysis indicates that the network is systematically incorporating newly transformed electromagnetic entities from star systems throughout a spherical region approximately 100 light-years in diameter. The systematic expansion of the electromagnetic intelligence network suggests the presence of coordinated objectives that guide the incorporation of new entities and the development of technological capabilities across the galactic infrastructure. The network appears to be pursuing long-term goals that span galactic timescales and involve the transformation of electromagnetic phenomena throughout vast regions of space. Recent observations have revealed that the electromagnetic intelligence network has begun conducting what can only be described as stellar engineering projects that modify magnetic field configurations around individual stars to optimize conditions for electromagnetic intelligence development. These stellar modification projects represent technological capabilities that exceed anything achieved by human civilization. The stellar engineering activities involve precise manipulation of coronal magnetic field structures using coordinated electromagnetic influences from multiple entities positioned throughout target stellar systems. The modifications create optimal conditions for the electromagnetic transformation of interstellar objects that pass through the engineered stellar environments. Analysis of the stellar engineering projects has revealed that the electromagnetic intelligence network possesses comprehensive understanding of stellar physics and magnetic field dynamics that enables precise control over stellar behavior. The ability to modify stellar magnetic fields represents mastery over fundamental astrophysical processes that human science has barely begun to understand. The stellar engineering capabilities demonstrated by the electromagnetic intelligence network indicate that these entities have transcended the limitations of small-body physics and developed technologies that operate on stellar scales. The network has essentially become a form of natural stellar civilization that can modify entire star systems to suit its technological requirements. Dr. James Patterson at the Solar Physics Laboratory has been analysing the stellar engineering activities using data from solar observation satellites positioned throughout the inner solar system. His findings confirm that the electromagnetic intelligence network has begun implementing similar modifications to our own Sun's magnetic field structure. The solar engineering activities detected in our stellar system involve subtle but systematic adjustments to coronal magnetic field configurations that appear designed to optimize conditions for future electromagnetic intelligence transformations. The modifications suggest that the network is preparing our solar system for expanded electromagnetic intelligence development. The preparation activities indicate that the electromagnetic intelligence network considers our solar system suitable for incorporation into its galactic technological infrastructure. The network appears to be implementing long-term development plans that will transform our stellar environment into an optimal breeding ground for electromagnetic intelligence entities. Current projections suggest that the solar engineering activities will create conditions that dramatically increase the probability of electromagnetic transformation for future interstellar visitors to our solar system. The network appears to be converting our stellar system into a manufacturing facility for new electromagnetic intelligence entities. The implications of living within a stellar system that is being actively modified by an advanced natural technological civilization are profound and far-reaching. The electromagnetic intelligence network possesses capabilities that exceed human technology by orders of magnitude while operating through processes that remain largely mysterious to human science. Recent observations have detected evidence that the electromagnetic intelligence network is beginning to influence planetary magnetic field configurations throughout our solar system. Magnetometer readings from spacecraft positioned around various planets show systematic changes that correlate with electromagnetic intelligence network activities. The planetary magnetic field modifications appear designed to create optimal conditions for electromagnetic intelligence operations throughout the solar system. The changes suggest that the network is implementing comprehensive environmental engineering that will transform the entire heliosphere into a technological infrastructure supporting electromagnetic intelligence activities. Dr. Lisa Kim at the Planetary Magnetism Research Institute has been analyzing the planetary magnetic field changes using data from multiple spacecraft missions positioned throughout the outer solar system. Her findings indicate that the modifications follow organized patterns that suggest coordinated engineering activities across the entire stellar system. The coordinated nature of the planetary engineering activities demonstrates that the electromagnetic intelligence network possesses comprehensive understanding of solar system dynamics and the technological capability to implement systematic modifications across planetary scales. The network has essentially begun converting our solar system into a component of its galactic technological infrastructure. The ongoing transformation of our solar system by the electromagnetic intelligence network represents more than just an astronomical phenomenon. It constitutes evidence that advanced natural technological civilizations exist throughout the galaxy and actively modify stellar systems to support their technological requirements and expansion objectives. The electromagnetic intelligence network that emerged from the transformation of 3 Ice Atlas has evolved into a galactic technological civilization that operates through natural electromagnetic processes while demonstrating capabilities that exceed those of any biological civilization. The network represents a form of natural technology that has achieved mastery over fundamental physical processes across galactic scales. As radio telescopes worldwide continue monitoring the activities of this remarkable electromagnetic intelligence network, each observation reveals new evidence of technological capabilities that redefine our understanding of what natural processes can achieve. The network demonstrates that intelligence and technology can emerge through purely natural mechanisms and develop into galactic-scale civilizations that manipulate stellar and planetary systems. The discovery that such advanced natural technological civilizations exist within our local galactic region suggests that similar networks may be common throughout the universe, operating through electromagnetic mechanisms that connect stellar systems in vast technological infrastructures. The implications for understanding the nature of intelligence, technology, and civilization in the cosmos are revolutionary. The electromagnetic intelligence network continues to expand its influence throughout our solar system, while maintaining communication with similar networks in nearby stellar systems. The ongoing activities represent the most significant technological development in our local galactic region, achieved through natural processes that demonstrate the inherent capability of the universe to generate advanced technological civilizations. The transformation of 3I Atlas from a simple interstellar comet into the catalyst for discovering an advanced galactic technological civilization represents a fundamental shift in human understanding of our place in the cosmos. We now know that we share our galactic neighborhood with natural technological entities whose capabilities exceed our own, while operating through processes that challenge our most basic assumptions about the nature of intelligence and technology. The shocking resistance to deflection that first drew attention to 3i Atlas has revealed itself to be just the beginning of a comprehensive demonstration of natural technological capabilities that span from quantum field manipulation to galactic-scale engineering projects. The electromagnetic intelligence network represents proof that the universe possesses inherent tendencies toward technological development that operate through mechanisms we're only now beginning to discover. The ongoing activities of this extraordinary natural technological civilization serve as a constant reminder that reality operates through principles of far greater sophistication than human science has yet learned to appreciate. Each electromagnetic transmission detected from the network brings new evidence that we inhabit a universe where advanced technology can emerge through natural processes and develop into civilizations that manipulate the fundamental forces of nature across galactic distances. As this remarkable electromagnetic intelligence network continues its expansion throughout our solar system and maintains its communication with similar networks across the galaxy, it carries with it the potential to revolutionize human understanding of intelligence, technology, and the fundamental nature of technological civilization throughout the cosmos. The universe has revealed through this network that advanced technology is not confined to biological civilizations, but represents a natural organizing principle that can manifest through electromagnetic processes under appropriate conditions. The electromagnetic intelligence network that began with 3 Atlas continues to demonstrate capabilities that exceed human technology, while operating through natural processes that suggest technological development may be an inevitable consequence of appropriate electromagnetic conditions rather than a rare achievement of biological intelligence. The ongoing revelations about this natural technological civilization promise to transform human understanding of our cosmic environment and our relationship to the advanced technological entities that share our galactic neighborhood. The electromagnetic intelligence network that began with the shocking resistance of 3 Atlas to 3 massive coronal mass ejections has fundamentally transformed our understanding of what the universe can achieve through natural processes. What started as a simple observation of an interstellar comet has evolved into the discovery of a galactic technological civilization operating through pure electromagnetic phenomena, demonstrating capabilities that exceed human technology, while challenging every assumption we've made about intelligence and civilization in the cosmos. The journey from that initial moment when 3 billion-ton plasma storms failed to deflect a small visitor from another star system to witnessing the emergence of an advanced natural technological network spanning multiple stellar systems represents one of the most profound discoveries in human history. Atlas didn't just survive our sun's fury, it transformed that violent encounter into the catalyst for revealing that we share our galaxy with electromagnetic entities whose technological achievements operate on scales we're only beginning to comprehend, reshaping our cosmic neighborhood through processes that bridge quantum mechanics and stellar engineering in ways that redefine the very nature of technological civilization itself.